Hello world! Welcome to this complete course on programming for beginners. So I'm very excited to show you guys. This is going to be a pretty long video, hopefully, where I'm going to show a lot of stuff for people who are interested or want to know more about programming or want to start programming from scratch. So you don't have to know anything at all about programming when you start this course, and hopefully by the end of it, you're going to be able to not only understand about programming, but actually do a few programs of yourself, have a solid knowledge, a solid foundational knowledge about problem solving, and maybe create a couple of exercises, and then you can maybe start like a more specific journey, maybe like game development or web development, things that you're interested in with a more solid foundation. So that's the main goal of this course. I'm going to introduce you general concepts that's going to be applicable to all programming languages. So that's pretty cool. We're not just going to sit here and show you guys a specific language. It's not going to be a specific language tutorial. We are going to use a specific language to learn all the practical things, but we're going to focus on the features that you're going to use when programming everywhere. So that's the main thing. And yeah, hopefully you guys will be able to solve the exercises and things. This is live, by the way. So if you're watching this from the future, this is a live stream that people are in chat, and they're going to ask me questions, and we're going to, maybe if there's anything that I didn't explain well, they're going to ask, okay, what about this? And then maybe we can do this a little bit more interactively, and it's going to be better for the future. Okay, and okay, another thing I want to, and I have tons of notes here because we're going to cover a lot of stuff. I'm going to start out very concept-wise, a little bit of theory about programming so you can understand what actually it is. And then we're gonna get our hands dirty, and that's going to be awesome as well. Okay, so how to best use this course? So I think that the best way you can do is like pausing and solving the challenges as we go along, because I'm going to present a lot of challenges for you, and I think it's important that you actually try to solve them. Maybe if you have a few difficulties, maybe you can watch a little bit forward, then you can go back and review certain sections. There are going to be time codes for everything I'm going to tell you in the video, but the main thing is about going at your own pace. So it's going to be a pretty huge video, but you don't have to watch in the whole sitting, right? I'm going to do this in the whole sitting, hopefully, but you don't have to. Hello, how are you doing? I'm great. Dead beef. Great. Okay, so first things first. Oops, I kind of screwed up my window here. Okay, first things first. What is programming? So when you think about programming, people think about writing code and things like that, like the how of programming, like the action. But programming is a little bit, more physical than that. Because if you think about it, there is the computer. I'm gonna try to draw things here in the stream. Maybe I'm gonna computer because I'm gonna draw that very well. So there's a computer, right, with a keyboard and a mouse and a monitor. Okay, so this, we are very used to it, right? Maybe we are used to it in this shape, which is like a smartphone or something, but it's basically the same thing. And these devices, they run software. Software are sequences of instructions that tell them to do specific things. Things like adding to numbers or displaying things on the screen, or a lot of activities and operations they can perform, right? So the act of programming is creating these softwares, so it's creating this series of instructions that the computer will run, okay? So this is what we talk about when we talk about programming. So it's creating these instructions that they can run. And why? Okay, so why are we going to program? Why should we spend some time learning and years mastering, right? Certainly. And this craft. Well, because we create all sorts of cool stuff with programming. Like right now, you're watching a video live, right, from all over the world. Right here, talking to you guys about programming, and all this was created with programming. People had to program the operating systems like Windows or Linux. Then the internet was programmed with tons of software layers on top. Then we were watching this in the internet through a browser. So programming allows a lot of good stuff, and of course, like video games and rockets, cars that drive themselves, right? Websites, so much more. And the greatest thing about programming, I think, is that it opens up possibilities for you to create whatever you want. So that's a pretty cool thing that maybe you can come up with your own crazy ideas and then make that happen. That's the greatest thing about programming. It's not only creating cool things that already exist, like video games and websites, but also coming up with new ideas. So hopefully this video is going to give you a taste of what it feels like to start in this craft that maybe you can pursue and then create even more cool stuff with it. Okay, but how do people program these computers? Okay, so this thing about computers is that when we create software, there's an implicit knowledge there that the computer is general purpose, which means that it has a series of base instructions that we can ask it to perform, but the way that we organize these structures and the way that we organize the data is actually going to be paramount to what's going to come up in the screen, how it's going to perform, right? So this is the how. We have to use these instructions that the computer, that the hardware, inside the computer are specified to operate on the data. So that's the basic idea. So I'm going to draw the computer. So this is the computer, right? This is the monitor and the keyboard. I'm going to draw the computer. I'm going to try to draw that in a perspective just so you guys can see. So this is the case, right? And it's kind of opened up like this. So yeah. And this like the motherboard. And you don't have to know everything about computers and stuff at this point. But there are two things that you're gonna have to understand to understand how the programming works. So this is the kind of the computer, right? And this is the CPU. CPU stands for Central Processing Unit. And you heard the word processor a lot. So this is what they mean when people say processor, CPU. They mean this chip inside the computer that does the operations. So these instructions that the software specifies are instructions that the CPU can perform. And these instructions are like add two numbers or move memory around, things like that. Throw in the word hardware at some point. And that's very interesting, Dandy. Good tip. So we're talking about software, which are the instructions that we tell the computer to perform. A good difference that you have to keep in mind is software and hardware. So hardware is the physical components of the computer when we specify it like this. So when I draw the computer opened up like this, everything here in the physical world is part of the hardware. So we're talking about the CPU, which is a chip inside the computer, we have the motherboard, and this is the memory of the computer. And of course, there are several kinds of memory. Some are faster than others and some are smaller than others. But for the sake of this introduction, think about the CPU that processes, right? So this processes. And this is the memory that stores, right? Processes data and stores data. So it's all about data. This is what computers are about, and this is what we're going to do when we program. We're going to specify commands for the processor to operate on the data, right? Maybe it's a little bit too abstract for now, but it's going to get very specific. For example, let's say this is the memory. Wow, that was really bad. Let's say this is the memory of the computer, right? And let's separate that into slots. We're going to talk a little bit more about memory later on, but for now, this is our memory, and this is the CPU. Okay, so let's kind of create a little bit of an instruction here based on a few commands that we can do to instruct this hardware, right, this piece of equipment to operate on the memory. For example, let's say that first of all we want to store. I'm going to use like keywords here that you may hear later on when we go specifically about programming and things. But yeah, these words are very specific based on things we're going to see later on. So let's store 6, which is a number, at position 0. So let's say this is 0, this is 1, this is 2. So I'm asking the computer to store the number 6 here. So, okay, when it executes this instruction, this is going to be here. And then maybe I can store the number 10 at position 1. Something like that. Okay, so when the execution moves to this instruction, 10 is going to be here. So it's interesting to realize at this point that the instructions that you specified are going to be executed in a specific order, right? Because the computer, like, it works on a clock base. So basically it's going to do like this instruction and moves on to the next one. And then you can do like maybe an add operation on things on position 0 and position 1 and store the result in position 2. So it's going to be adding 6, which is in position 0, to 10, that's position 1, and then it's going to store 16 here in position 2. So it's okay if you don't follow this perfectly, but the basic idea is we are going to create instructions, not exactly like this. This is just an example of how the CPU works. because people program a little bit differently today, which we're going to see in a second. But these instructions are going to specify what the processor is going to do, and the processor is the main brain, let's say, of the computer. Okay, and these instructions are going to operate on the memory, like we're going to see in a little while. So hopefully that gave you a little bit of an idea about what programming is in the real world. So that's the thing that I want to show you guys first, before we dive into the practical things about the everyday of a programmer, right? Understanding what you are doing in the real world is kind of interesting, because when we start typing codes and things like that in the code editors and compilers and things like that, all we're going to do is specify in one way or another commands for the computer to execute. And it made me think, oh, it's going to be hard. How can I do this all by adding these numbers and things like that? That's what we're going to see in a while. Please don't erase. Keep the graphics and move somewhere. Exactly. I'm not going to erase. I'm using a pretty cool software called Newton that I have a pretty much an infinite canvas here. So yes, thanks, Dandy, for the tip. So now we're going to talk about how we do the instructions. So how to specify the instructions. So you can imagine like the instructions. So you can already imagine that one way to do it would be to actually see at all the possible instructions the CPU has to offer, like storing things and adding and then moving things around, right? And then loading things, and just specifying these instructions. And that's what people used to do in the very beginning. But now, a very common way to do that is with a programming language. So programming language, and you probably heard about this before, right? Programming, language. So a programming language is a specification of things we can understand as human pretty easily that can be translated to commands that the computer works with, right? So when you think about programming language, maybe you heard like things like C and C++, and maybe things like Java, things like Python. So there are tons of stuff. Maybe you heard things like assembly, or maybe you heard about blueprints in Unreal Engine that you make video games with, which is an interesting way of programming with visual nodes like that you connect like this. Scratch is another interesting way that people start programming with, which is another block-based language like this. Well, not exactly like this, but visual. So when you think about C and Java and Python, you think about kind of a text code, but then there's also like this category of blueprints. There's also things like HTML, maybe you heard of that before, and like CSS, which are like, so when you think about programming language, there's a lot of different stuff that you can think about, right? But the basic idea is that careful behind the webcam. Okay, careful writing. Okay. Oh, because it's not completely aligned. Yes, it's not. Okay. Oh yeah, I think I'm gonna make myself a little bit smaller so you guys can see a little bit better. Thanks for the heads up, Andy. Okay, so programming language, there's all sorts of crazy ones that can be very old school, like just typing text, can be very something interesting like connecting nodes. But the basic idea is there's some interface, right, that us humans use. So I'm gonna draw a human. This is a human. Okay, but the computer, or specifically the CPU, right? The CPU must execute its own instructions. Okay, so I'm going to call that computer, or maybe machine language. We're going to use that term, machine language. Maybe you heard about binary, things like that. I'm not going to get into this in this tutorial, but the main idea is that we want to interface with these instructions in a very easy way. So maybe programming languages can help us with that, and maybe even things like visually seeing what's going on. But how does one thing convert to another, right? That's where a compiler comes in, right? So compiler is a term that you're going to hear a lot today. Compiler. There's also a thing called an interpreter. So these are computer programs, so software, just like we've been seeing. So just computer programs, right, that are able to get this get data in this format, so it's specified in a programming language format, and then convert that to a machine language. So when you say compile a program, things like that, all you're talking about is transforming the data from a format that you can easily see to a format that a computer can understand. And this is usually, if you're like on Windows, you're gonna see this around like .exe file, which means the executable file. Executable. This file is the file that contains the machine code that it can run. Okay, so the compiling is the process of transforming this into this. Okay, and the interpreter also transforms code into machine language, but it does that in a real-time sort of way. Like when you compile the program, before people actually run it, they transform every piece of code that you wrote into an instruction for the computer. And then when you run the program, certain instructions are going to run based on the conditions that you specified, right? The interpreter, however, is going to transform the code into the machine language as you run the program. So for instance, if you do a certain condition, then it's going to execute certain parts of the code, then it's going to transform that into machine language. I'm not going to get into the details of one versus another and like the advantages of each one, but I just want to know that both these processes refer to transforming human code into machine code. Okay, so that's the basic idea I wanted to get across. Let me get a bit of water here. Okay, another distinction that you may hear about when you see programming languages are low level and high level. The basic idea to understand here is that this is what they actually, well, this is like this is kind of our representation, right, of the instructions that the computer can execute. But if you imagine that there are a series of instructions that it can execute, when you say a low-level programming language, is that the way that you specify your code is very close to the way that it actually is materialized in the real world. Like it actually maps to the instructions of the computer, the ones that you actually need, more high fidelity kind of way. Like, so if you imagine this as a line, this is like low level. Low level is very close to the machine, what the machine actually executes, right? And high level, when you say about, oh, I'm doing a high level programming language, means that it's further away. So the concepts that are actually real in terms of executing machine instructions are going to be further away from the actual machine instructions, but it gets converted into that anyway. So when you talk about games, for instance, maybe parts of the game are very low level where people can actually know what exactly is going on, but some parts are higher level because maybe it's faster to iterate on, and the higher the level, the more like the transformation has to occur in terms of your code and the machine code. So this is just something to keep in mind, that there's usually a distinction between how close you are to understanding the exact machine instructions. Okay, that's just another thing I wanted to get across. Okay, but that was probably a lot for you, right? You're probably thinking right now, oh my god, this guy is just saying a lot of stuff. I'm really confused. I'm not sure now how to get started because, okay, I kind of understood what programming is, that we're going to specify instructions, but we can do that in so many different ways. I'm not even sure how to get started. And that's interesting because some of these ways, like blueprints, for instance, or HTML and CSS, are really created for specific use cases. Like, okay, we're going to make video games, or maybe I'm going to make websites, and assembly, maybe I'm going to do like something very specific to the hardware itself. Remember the hardware about the components, right? The physical components. Or maybe Python is focused more on AI kind of stuff. So there are tons of options. So now we're going to get started programming, but the question is, how are we going to program this way? So in order to solve this problem of the overwhelming things that you can face, I'm going to introduce you to a novel way to program, especially a novel way to learn programming, which is pretty cool, I think, which is called Vizzcode. So they kind of map into this possibility. So Vizzcode is a development environment, and you're going to hear this term a lot, like development environment, which is where you're going to program, the programs that you're going to use to execute the code, like compile or interpret, and then execute, and maybe find bugs, like finding problems that you have. And it's a development environment that kind of combines higher level representation of code with lower level, right? So if you think about blueprints, for instance, which is connecting nodes, right? I'm going to show you guys in a second. It's going to be clear. As something very easy to get started, but it's kind of far away from what the computer is actually doing. Vizzcode bridges that, and I'm going to show you guys right now. So this is the website you guys are going to download to follow this course, right? Vizzcode.com. And it says use visual and textual coding to learn programming. So the idea is that you're going to be able to connect nodes to quickly get started programming. So each node is going to be an instruction for the computer. So you're going to be able to instruct the computer to draw things on the screen, maybe draw text, maybe read text, do operations. All this in very easy to do format. And then the text code, which is kind of the main way people program nowadays, will also be there for you. And you'll be able to learn one while doing the other. It's going to be, you're going to program both ways interchangeably. So that's the main thing that I want to show you, is how easy it is to get started without losing this connection. Because other ways that like Scratch that kind of wants to introduce programming in a visual way, they kind of focus too much on this part. And in order for you to learn like text-based languages that are a little bit more like here, or even lower level languages that are used professionally like Java and Python, it's a big jump, right? So what I wanted to show you guys is this way to create instructions that it's easy to get started, which is going to be the focus of today, but also easy to learn how that translates to the professional ways of programming. Okay? So it's going to be super easy to get started. We're going to click Get Started for free, and then there are two plans, a premium one and a free one. But you can get started for free and learn a lot with it. It's gonna be great, and you're also actually gonna get premium for 7 days by registering for the free version. Right? So let's do this really quickly. I'm gonna create a username. Okay, I'm gonna add some passwords, and then I'm gonna register. Okay, so another interesting thing. So you connect the two worlds with text and visual. Cool. Exactly. So that's the basic idea. This world of higher level representation of code is usually easier for people to get started with because they have less detail to think about. But they kind of miss a big part of programming, which is actually what the CPU is doing all the time when they completely ignore this part, right? So what we want to do is bridge these connections here. So you can start high level and then easily transition to the low level as you get better at it, right? So that's the main idea. And we also wanted to simplify a lot of this stuff because, like, if you think about downloading, like I'm just going to click download the latest version. When you think about downloading things like developer tools and things like that, it's usually very hard because they make it really complicated for normal people to use, and it kind of sucks a little bit. So we wanted to simplify that a lot. I'm going to install that quickly just for you guys to see. Well, Windows did pop up a security warning because not a lot of people downloaded it yet. So I'm going to click Run anyway so we can get started. So this is the installer. I'm going to choose a location and I'm going to click Install. That's it. That's installed already, right? And then I can start learning. I'm going to minimize that and make sure that you guys can see the whole thing. Just expand to make sure that the window is properly okay. And another thing I want to show you guys is that if you're learning by yourself, or even if you want to expand the learning we're going to do in this course, you can check out the documentation here, which is another thing that usually it's really bad in terms of like learning programming is the documentation. Right here, there's a lot of stuff like we just did like installing and stuff. We're going to take a look at using it in a while. But you can really get started like your first program, and maybe how you can troubleshoot and how can you distribute, what happens when there are errors that we're going to see in a while. What about transforming data, which like we saw is the heart of programming, transforming data, and then making more programs. And then the exercises, we're going to do a lot of these exercises today to get started because, like any craft, you have to really practice to get good at it, right? So we're going to do a lot of these today, then you can get really specific, and of course, you can make games because all this, let me go back. All this like instructions. The first thing we talked about, right, was the why. Why do we program? Is to create cool stuff, right? Is to be able to create interesting mechanisms that we're going to make life easier or life more entertaining. And games is one of my big passions. So I'm gonna show you guys, not in this course, right? But this course is gonna introduce you to the concept that you need to know to start learning how to make games later on. It's gonna be really cool. Okay, then you can do like complete tutorials. Everything's hidden here. But now let's get started. So I'm gonna log in. And the first thing that you see here are the tutorials, right? Because it's a beginner-focused tool. Sorry about that. Talking a lot, right? So you can choose like tons of tutorials. Like there are introduction tutorials, like I've never programmed before. What am I going to do? Like this is like the very first one. It's going to explain how to navigate, how to compile, things like that. All the way to more advanced like features that you're going to use in the language. And or maybe you just want to get started quickly. You already know how to program. Maybe exercises like we saw. I'm going to do a few of those today. And then game development, which is like one of the juicy stuff. Yes, we are going to make games using Vizzcode, but not today. It's going to be pretty cool, and then you can see all of them here. I'm going to create a new project, a blank project here. I'm just going to leave the default name. You can choose like a location to create the project. That's it. So this is the base environment that you're going to see when you're programming with Vizzcode. And like I said, each programming language and each programming environment that you use to compile and execute the code is going to be a little bit different. But the basic idea is the same. You're going to represent your commands somewhere, either using text, like in this panel here, or with nodes, which are pretty cool, which you're going to do in this panel here, right? So for instance, if I just start typing, as you can see the cursors up here, if I just start typing anything at all, text start appearing here. This is just like normal text. There's nothing to it, right? When you choose a tutorial, we'll also show on the screen. Yes, good question. Let me just show you guys here back in the main page. The tutorials are like embedded inside the platform, so you can program while learning how to program, right? You don't have to like jump around to different things. Like, or if you just create a blank project, it's blank. But these tutorials that you can choose, it's right inside the platform. It's going to be pretty cool. Right, so the text is just normal text that you can write like in a word processing program, things like that. And the nodes are pretty cool as well. So I'm using the right mouse button to drag around. I can also click with the left mouse button and drag this pin here. Then appears a little screen I can click off to make it disappear. I can use the scroll wheel to zoom in and out. And we're going to actually create things in a while here. So yeah, the basic idea is you're going to type some commands in a specified language, or maybe a visual language, or maybe a text language to the computer, and then you're going to compile and run, just like we saw before. Compile is get what you wrote and transform that into a valid program, and then you're going to ask the computer to execute those instructions. That's programming. Just for the fun of it, I'm going to click compile right now. What you guys think is going to happen? Because I just have a blank file here. I'm not asking to do anything, like creating no nodes here. Just going to click compile. I'm going to ask it to transform whatever I have here, which is nothing, to valid instructions. It's gonna complain, right? Empty code. You must type or add nodes to compile the program. Okay, and there's also a link if you're not sure how to get started here. So I'm going to see the options here. Import library, new procedure, new variable. I'm going to create a new procedure. A procedure is simply a body of code to be executed. So we talked a lot about instructions and execute instructions, things like that. They are organized in procedures. You're also going to hear the term function in a lot of languages, or maybe methods, subroutines. There are a lot of terms, right? But procedures is the most general one, which means a body of code, right? Some instructions. So I just created a procedure, which is like I added a node, right, to get started. So my program is specified something like, okay, when it starts, like in the global scope, we're going to see a little bit more of that later on. There's a procedure, right, which is a body of code. Let me try compile now. Okay, so I still have an error, and that's okay because the errors are going to help us build a better program. So you don't have to be afraid of errors. Can I move and customize the windows like if I have two monitors? Not yet. So the windows are fixed, so you can't like make them larger or smaller of yet. But that's something that we're going to improve on Vizzcode in a while. Good question. Okay, so no entry point found. Okay, so now we're progressing a little bit, right? The program must have a procedure called main to start the execution. And that's something very interesting because we just talked about how, let me go back to my pen here. We just talked about how it's going to execute them sequentially, right? So first of all, it's going to be this one, then it's going to store 6 here, then it's going to store 10 here, then it's going to add the 2 of them and start here, okay? But it has to know where to start the execution. And that's where the main procedure comes in. So the procedure, like we saw, it's a body of code, but if I rename, and I just double-clicked it, so if I rename that to main, it automatically kind of tells the operating system, right? It tells the compiler that this is going to be the point, the entry point of the application. So if I compile now, I get a compilation successful message. And there are a lot of cool stuff happening right now. Okay, so just like we saw before, compiling means transforming this into actual code. So if the compilation was successful, it means that there is somewhere in our computer a file that the computer can run to create the program. So I'm going to open up Windows Explorer here. I'm just going to off screen just for a while. I'm going to go to the, well, it was called Untitled 28, right? That was a pretty bad name. So let me just find that really quickly. 29, yeah. So this is the project that we created, okay? And you can see a couple of .Vizzcode projects like Vizzfile, Vizzcode project files, okay? These are the Vizzcode project files, but there are 2 executables here. There are .exe and _.exe. Why isn't the first proc you add automatically named main? You know, that's a good point, Dandy. Maybe it should be the default, yeah. Because like there's a search filter here, so if we call like procedure or new procedure, it's gonna appear. If I type main, it also appears. So there's that, but yeah, so you don't even have to create it. So that's a good point. You know, another point that people suggested was that blank projects already start with this setup. And I think that's also a good idea because you see, we're gonna do this a lot. This is not gonna go away today. So we are going to have always a main procedure, which is going to be where the program starts executing. So everything that we ask it to execute in this procedure is going to start out first. So nice suggestion. But the cool thing that you guys probably noticed is that the moment that I created this procedure right here, this code appeared. So this code is kind of a text code with like curly brackets and like parentheses, something that you may have seen or kind of like this when you think about programming, right? So we think about text that people program with, type, right? Things like this. So that's the good thing about Vizzcode is that it's very easy for us to create procedures like this, and then it's going to automatically generate the code here. So you can see the equivalent of like most programming languages, they are textual, right? How you can represent a procedure creation. Now the thing to note is that each programming language is going to have a different way of saying the same thing, so to speak, right? So for example, I'm creating a procedure like this with this square in this representation. Like this, I'm doing the same thing, but I'm typing like the name and then like this colon twice, then parentheses, then curly brackets, and in some other languages I'm not going to use this. I'm going to type function or maybe func, or maybe I'm going to use like a keyword to tell you a specific thing. The bottom line is why are main and proc connected in the graph? So everything in the program is going to be connected to the global scope. Imagine this as the file, okay? So everything that you add here, and we're going to add here and here as well, right, are going to end up connected this one way or another. Even if you have like more complex expressions, as we're going to see, they are all going to end up in the global scope start. So it's going to be clear later on. But the interesting thing to see is that the code is going to look a lot with a visual representation, right? So they're going to look alike. That's what I'm trying to say, especially when it gets a little bit bigger. So you're going to see the parallels and be able to easily transition from one to another. But shouldn't proc be connected to global scope? Okay, so that's a great point that you added. I'm going to show you guys what each node, what each connector, in a node means, okay? Because that's important to see, because that's the base language. When you understand about a single node, then programming this language is super easy, right? Thing is, see that this connection entered here, and there's also like a ghost node here. If I disconnect it with Alt-click here, and like this, there's no connection, right? So if I connect it like this same connection is going through the node and then back to this guy. Okay, so if I connect like this, the global scope has main and has proc. And this is going to be really important when we start, pardon me, let me get a little bit of water here. It's going to be really important when you start adding more instructions to it. Okay, so this connection, this white line here, is going through the main and all the way to proc. If we add another one, let me add a new procedure. I'm going to call that proc2. I'm going to see that in a while. So as you can see, the global scope starts here. Main is inside the global scope, and then proc, and then it's also going through it, and then proc2. Okay, so that's the basic idea. And these other connections that we're going to do, I'm going to use in a while, are specific to this node. Like the main node has an execution, has these other two that we're going to see. This other proc has this other execution. So this is the basic idea of the nodes. Okay, just a couple notes. When I created a proc like this, you see that the panel was locked. Locked panel compiled the program to unlock the text editing. What does that mean? Well, our code here is invalid. And if I compile, it's going to see the error, right? Multiple symbols were declared with the same name, proc. So this name, this node here. And this other node is where the other symbol was declared. So they have two procs, and you can't have two things, I'm going to call them things, right? Two things with the same name. Okay, they are like, you can think about that as identifiers, things like that. But if you're going to use the name to refer to this procedure, you're not going to be sure which one you're referring to if they have the same name, right? So I'm just going to call them proc2. Okay, and we're going to see a little bit more about that later on. But I'm going to delete them and go back to just the main procedure here. But now I'm going to run, right? Because I was showing you guys that we have executable files. So when I click compile, actually if I even delete these two guys, now I only have the project and the code. If I click compile, you're going to see that the executable got generated again because, like I said, the code got transformed into machine code. I'm going to double click this guy. I'm going to show you guys the difference in a second. Like this guy, and it says end of program. Press any key to exit. Okay, so that was something, right? And if I run the program from inside the platform, it's going to be the same thing. Executing the executable file, right? So compile is to generate the code, the machine code, and run is to actually open the file and execute the instructions, the machine instructions. But there are two of them, as you can see. This one, the one that we opened before, kind of had this message, end of program, press any key to exit. And if I open this one, I don't think you guys can see, but like it's opening up and closing very quickly, as in like you can't even see what's going on. Because we're not asking it to do anything, right? We're just saying, okay, there are procedures, so there's a body of code with instructions, but there are no instructions. We're not asking to execute anything. So this guy doesn't do anything. And this other guy, the guy with the underscore, has this message in the end, so end of program. So we opened up, so we ran the program, it automatically ended. So not too much going on, right? I wanted to show you guys what was going on with the executable, but now I think we can work from inside of Vizzcode. Okay, so but what can we do that's actually interesting for our program? The very first thing that people usually do when learning how to program is have the computer say something to them. Because that's one way of like interacting, right? Maybe it's only a one-way interaction, but it's working, right? So maybe we want to execute something here that says, okay, show the user a message, right? Because this window that we opened up here, it only has text capabilities. And I'm not sure if you are, if you've seen that before, but this is kind of the command prompt that people used to use to control their computers way back in the day, but they're kind of still used now. This is the default way that programs execute. So when you think about a program with like a window, like a video game, or this program that has a window, it has text, it has images, it has like the cursor, this kind of window applications are one kind of program that you can create, like video games that we're going to see later on. But for now, we're going to start with console applications, applications that you run in the command line, which is simply a way to interface with just text, which is easier to get started, right? So that's what we're going to do now. So if the interface is just text, we can show text to the user. And this term show text is started about as printing a message, right? So you're going to hear the term print a lot when talking about showing messages to user, especially in the command line, which is this black console here. I'm not entirely sure why it's called print, as in like it's not printing a piece of paper or anything like that, but that's the term. And since Vizzcode wanted to show you how, because he used to print a piece of paper. Okay, so Dandy gave us a pretty cool history lesson for us now. So before monitors is, oh yeah, because we're talking about way back in the day, right guys? Yeah, so we're talking about way back in the days where computers didn't even have monitors and like keyboards and things like that. So do I need constant internet connection to be able to use? No, you do not. So a question was, do I need to be connected to the internet to use this program? No, once you log in once, you can use it for as long as you need, as long as you have a valid license, right? And the free license is forever, so you don't have to worry about internet connection. Like if the internet drops or if you're not connected offline, you can use the program all the same. It's not like always online or things like that. The login is just for the first time verification. So yeah, so before, I'm gonna put that thing in the side of the tablet, the tablet I used to draw, because otherwise I'm gonna break it because not a lot of room here. So yeah, so before it's called print because people actually used to print physical pieces of paper. Hello everybody, it's good to see you here, man. It's been a while. And nice that you were able to catch this live. So it's called print. Now we're never going to forget that, right? So whenever you need to show a message, a text message to the user, we're going to print the message, but it's going to be a digital print today. Okay, so in order to use the print, we don't have that command right off the bat available to us, because some of, like we said, the commands that the machines understand are very basic, right? They're general purpose. And then people use these commands to build more complicated commands and pack them together. So every release, is that what you're working on? Exactly. So this is the program that I've been working on for the past 6 months. It's pretty cool, and now it's in a great shape that I can show you guys, and maybe you guys can check it out and download. It's called Vizzcode. It's going to help you have a greater understanding of programming. So we're going to start out really simply. So that's what we're going to do today. Just show you guys how to program from the very beginning. We've been talking a lot about the theory of programming, what it actually is. I drew a lot of stuff for you guys. Now we're going to get our hands dirty and actually do code that the computer can understand and create cool programs with it, and maybe some even more cooler programs in the end. Okay, so these instructions that like print messages, they were packed together in what's called a library. So a library is a lot of instructions, a lot of procedures that people created in the past that has a specific use. For example, I may have a print library that is used to print messages, because otherwise I would have to do all these sorts of stuff like starting and adding things and moving things around in the memory and the messages here, now it's in the monitor and sending that to the graphics, all that stuff every time I need to print a message. So people create procedures like this, like the one we're creating, right, that encapsulate this idea of printing. So all you have to do is call the procedure, right? It's calling the procedure, and that it will run the code that it needs to do whatever it wants to do, like printing a message. So to get that procedure, I'm going to import a library. So I'm going to drag from here. I can also drag from here. It's the same thing like we were talking about before. Like the global scope is up here and up here, and it doesn't matter now. So I'm going to import a library. I'm going to call that print with capital P, like this, print. So as you can see, we got a little bit more code here. I'm actually going to put it like this because I think it's more organized. So first we're going to print. We're going to import the print library, and then we're going to execute the commands. And what commands are we going to do? Well, let's see. If I drag off, there are a lot of commands here. Well, not a lot of them, but quite a few. We have like main and print int, print float, print, I don't know what that is, return an if statement, all that crazy stuff. Well, we're talking about print, so if I want to show a message, I'm going to call print. Okay? So right off the bat, you see that this guy appeared here. and we have print, and then message, then like an empty text box. I'm gonna try to compile and run as is, just to see what's going on. So transform this into code, into machine code, right? And then run. Hello, so we got a message already. So that was easy, right? Okay, so, oh, so then he showed us a picture. That's gonna be pretty cool of of printing. That's kind of a so this is what you guys should think about when you're printing, right? So it's called print. Wow, that's awesome. Teletype machine, Dandy is saying. How old are you, man? were you around where people were printing like this? Right now we print like this, right? It just says hello here. Imagine printing a. That's gonna be interesting because now it's very it's pretty cool. When we're talking about programming, not that old. When we're talking about programming, it's a very iterative process. So we're gonna program a little bit and try to experiment, see how that looks, and experiment very a lot of times really, very iteratively. That's the word. Back in the day and in other fields, you can't really do that because there are physical constraints. Like you're gonna really use a piece of paper every time you want to say print just to make sure that it's working, right? So that's one great thing that we can do in programming. It's not like scarce, right? We can just compile a lot. Well, it's opened. Have to make sure the executable is closed if I try to compile it again, and then I can just keep running it. So yeah, but let's type our own message, shall we? As you can see right here, it's kind of a little bit grayed out, but there's like quotes and then hello, and then there's like this thing. I'm not sure what that is. I'm gonna open up quotes and type, I don't know, live course, which is cool, and then we're gonna end the quotes. And when I do end the quotes, you're gonna see that this lock is gonna go away because it's valid code. And then it's gonna be the same thing here, live course. Let's compile and run. Perfect. That's what we needed. Now we can type whatever we want for the user. Maybe you're gonna type my name. So my name is Dan. And now the computer says my name is Dan. Well, maybe now it's the computer's name as well, right? So that's a very cool thing that we just learned. But why was hello not in the print statement before, but when you changed it, the text appeared in the code? So that's a good question, and we are going to talk about it later on. But just to tease you guys, is because we are calling print. And like I said, print is a procedure like this one, right? The things that I can pass to it, like this message, are called parameters. And as you can see, I can pass a message like we did, right? Yeah, so Dandy already caught it. So this message has a default value of hello. So if I don't do anything to it, so if I just call print, or in this case, if I just add a node here, print, it's just going to say hello by default, right? So if I just compile and run, it's going to say hello and hello again. But if I want to do a my custom message, one way to do this is just to type here, like my message. My message. Oh, if I can type right. Okay, then I can compile and run. Okay, so something interesting happened. We printed my message like we asked, and then hello, right immediately after. So that's a good lesson to learn about computers, is that, like I said back then, all it can do is like process information and store data, right? Process data and store it. So it's only going to do what you tell it to do. And that's a very important takeaway. It kind of sounds like an obvious thing, but once you really understand it, the problems that in the code is going to be evident, they're actually problems of communication between you via this programming language, to the computer. So what we are asking it to do, it is doing, which is print, right? So write to the screen, my message, then write to the screen, hello. So that's what it's doing, but that's not exactly what we want to do. We actually want my message, and then we want to skip a line, like add a new line, right? And then type hello. So that's what this backslash here, n, means. Backslash n, that's what that means. It means new line. It's the code for a new line. And you might find it weird, and programming does have a little bit of some weird conventions, right? But there are some really good explanations of pretty much everything, like the print thing. I was like, why is it called print? And then we just learned why is it called print. So there's a lot of things like that in programming. So the idea is that you must be open to understanding what exactly you wanted to do. Exactly. Like, print my message, add a new line, then print hello. I'm going to type hello so it's easier for you guys to see. I'm going to type hello like this, hello. And then I'm just going to end it here. So that's what it does. My message adds a new line, hello, and the program finishes. Okay? So that's it. That's the basic idea. And we are creating programs with it. It's like, it was kind of automatic. I was hoping for like an aha moment of, we finished our first program. But it was so natural because there's really not much to it. I mean, we are specifying things. I'm going to go back and review the whole thing, right? So when this global scope is the start of the file, like I said, like if we zoom out and things like that, you can already map, kind of map, right? What's going on? Like we have the beginning of the file here, then we're importing print, and then we have this red node, which is the main procedure, and then inside of it, like see that's in the curly brackets, we have two nodes, right? The print message, my message, and then print hello. So we are specifying some commands in this programming language inside Vizzcode, right? And then it's going to compile to machine code, which is code the computer understands. So no matter what language you use, it's always going to be machine code when it's executing it. And different computers, different processors understand different code, but that's not really important for now. The important thing is that once we make that an executable file, I can just run it, okay? And just to go back to the idea that we discussed about having these two guys, this one executes the program and then keeps the window open, because even if we execute this one, there's nothing, just like when we didn't have anything in the program. It was like, okay, but why can't you see? Well, it is printing, but like I said, the default behavior of programs is to use the command line interface. So it's printing to nowhere. This program actually stops the command prompt that it creates so you can actually read what's going on. So there's this key difference here, okay? And if we are inside a command line, don't worry too much about that, but if you're inside a command line, like you may have seen in movies and things like that, you can also call the program to execute. And then I called it without the underscore. You saw these two. Don't need to worry about this too much. All you need to know is that there are two kinds of programs. Programs that open up windows and open and programs that do not. This program does not by default, so it's just printing to a command prompt. Okay? I think you guys got that. If there are any questions, let me know. Okay, so wait. Is that compiled to an intermediate language and then to machine code, or to machine code directly? This is machine code directly. So this is this. So there's no intermediate language in terms of like compiler, right? I mean, yeah. If you talk about like internals of the compiler, then we can talk about that. But not to make this too complicated for newcomers. This is only you have to care about. I mean, this code is this code, it's the same thing. So if I delete this guy, this one disappears. If I like change the message here, I was going to get to that. Like I'm going to create a new one and then delete here. It also goes away. This code is the same as this one, and then when I click on file, it becomes machine code directly. So when you execute this program, it's actual machine code that you create with this program. That's a pretty cool thing, because most high-level languages that we talked about before. Oh, I don't know if I think I lost my connection to. Oh, I didn't. Okay. So we talked about high-level languages. Most of them don't connect directly. Like I said, it's a long way. It's a long way from this nodes to actually machine language, right? But we actually do the whole thing. So you're going to learn all the process when you use it. You're going to see this, which is pretty easy. You're going to see this, which has its own quirks that you're going to learn in time. And then hopefully you're going to be able to program whatever you want with it, right? So another thing I want to show you guys before we get to the good stuff in terms of like features of programming, right? Because we just learned this one instruction so far, right? Is about this print thing, right? Because in text, I mean. Because right now, like I said, I was typing things here before. But now it typed for me this text. What can I do with it? Well, we learned that if I add this node and type a message inside, I'm going to have a print command for the computer, and it's going to execute when I run, right? and this code was generated, which means that in text form, this command is called print, and then I open parentheses, and then like the double quotes message, just like in here. Then I close parentheses, and then I add a semicolon. So let me try typing that here as well. So I'm going to type print, open parentheses. I'm going to type hello. I'm going to type the message that was before. So hello, exclamation point, backslash. And the backslash is just on top of the enter key, for you guys, if you don't know. I'm closing up parentheses and add the semicolon. So it created the node for me. So that's the great thing about Vizzcode. So you can also program this way, because you're going to see there are going to be advantages to programming in text. That's why people program in text, like professional developers program in text, right? Because it's a pretty good interface, but it's hard for beginners. So right now, you can just play around with the nodes like we were doing. Like, let's add another message like hi. Then it's going to be updated here automatically. Maybe you can do like hi there or hello there. See? So by doing this, you're going to learn how it looks on text. And then by playing around with it, maybe you can just playing around with the message. And then like do another print. Just going to print a lot of new lines and then my name. Just my name really. And then by learning how that works, you know, it's going to work like this as well. Vizzcode looks really close to other languages like Python, JavaScript, and C, right? Exactly. So like I said, there are a lot of programming languages you guys could choose, right? But in order not to be too overwhelming, Vizzcode kind of created its own language that it's a very simplified version of the language. So languages like C and C++ and Python has a lot of quirks, you know, small mechanisms. They are great for like professional developers, but really makes learning difficult. So we chose a language. We didn't do like a complete like raw language. We did want to add substance like the semicolon. Semicolon is the thing you're going to see in a lot of languages. So we put that in Vizzcode so you can get used to it and see, okay, so if I finish typing a command or a statement, as we're going to see, I finish it with a semicolon. So these are the kinds of things that you're going to learn as time goes by. So instead of learning like a language like it was asked, like Python, JavaScript, or C, right off the bat, and have to deal with all that syntax stuff all at once, you start out really easily, and in small ways, slowly, I mean, you're going to be able to transition to this language and then to another language, because that's the thing. This whole thing we've been talking about commands and libraries and print and calling, it's pretty much the same thing of all languages. Like I said, this is going to be different. Like instead of like doing this, maybe you're going to be like this instead. So instead of doing like the print parentheses, maybe there'll be no parentheses and just a space like this. So it really depends on the programming language, but that's the small syntactic details. Syntactic details, I suppose. So we wanted you to focus on the logic, okay, and apply that logic maybe on this language, as you can see it being formed, or another language if you want to go to a domain-specific language later on. So Timo was asking if Thiago, which is in the chat, is part of the team. Yes, the team is my brother and I. 2 people are creating this from scratch, and it's pretty cool. So if you go to our website, there is a About Us section, pretty cool. Oh, you can actually see us. You can actually see me. So that's me, and that's my brother. So yeah, that was totally off script here, but you can see a little bit about our history here and our motivation behind Vizzcode. And we are creating this by ourselves, and it's a lot of work. So yeah, hopefully you're going to be better in time, right? Because as we have more time and more feedback from you guys to what works and what doesn't work. Dang, you look like brothers. Exactly. So that's good, right? If you didn't look like brothers, I'd be worried, Dandy. So yeah, we pretty much look like brothers. Like, of course, I'm very much more handsome than he is. But with that note aside, you know, yeah, we pretty much look like brothers. Okay, so we learned our very first program. So, okay, so I have a question. I started learning coding and chose C++ for my first language. The issue is that I feel like I'll need 4 lifetimes to be good enough to get a job, even when I don't know how to use, if you know what I mean. Any tips from me, since I've been thinking about quitting altogether? I know exactly what you mean, because when I first started programming, I started with C, not C++. It's been a while. but I learned the basics of the language, like what's an if. We're gonna see all that today, but what's an if and what's a variable. And I could copy the code, right, and see it working, but I didn't actually develop the understanding, which is pretty interesting up until I was making games. And the thing about that is that I was making games using visual programming in Unreal, right, using Unreal blueprints. But the thing about the way I learned later on with blueprints is that it's very domain specific. So it's just for making games in Unreal in this way, specific way, right? So, but I learned the logic behind it, and that was really valuable. So once I learned the logic with the nodes, I then went back to C and C++, and then I actually learned how to program with text. So I pretty much learned 3 times how to program, right? So first of all, I learned, like I said, I chose one of those many languages that are available, and I found it was too much for me. I mean, I could copy the code and things like that, but I wasn't really understanding how to express myself. And then I programmed a lot with visual coding. It wasn't Vizzcode, right? Because there was no Vizzcode back then. But it was a similar way, but very specific to games and making games. And then I learned the logic. And then when I learned how to apply the logic with all the syntactic things, like you're going to see in C++, is going to look pretty much like this. Or yeah, pretty much like this. Then I could actually be able to express myself like I was with visual code in text code. Then I could create big software, because you can't in visual code so far, because there was no Vizzcode back then, right? You can only do like very specific things. Here I can create this program, like we've been doing, like the hello, my message, hello, hi, my name. This kind of program is the one that you start with usually. You will require a real programming language. So yeah, it would be pretty hard. Yeah, so he's adding to the question, I'm following a C++ tutorial. Even when I learn something new, I don't know how to use it altogether. So that's exactly the problem I had. And the way I solved the problem was programming in a different way. Like I said, programming is all about generating machine code. So, so yeah, this guy, the CPU, needs to do this, right? But how you're going to create these instructions is up to you, right? You can do it however you want. You could use C and C++, or maybe Java and Python, or like assembly and whatever. And you could use like other weird things like blueprints and Scratch. But I want to introduce you guys to Vizzcode, which is this tool right here, because it really helps you in this fundamental point, which is I want to get started, I want to learn the logic, but I don't want to get stuck with all these hard things to process, like why do I need to put a semicolon here all the time, things like that. All you can do is just open up here the options and play around with it. Maybe, like I said, we can compile with errors and solve the errors. So what I recommend to you, man, is go to Vizzcode.com and follow this tutorial. I mean, it's live, so you're going to have to watch the VOD later on. But if you stick around, you're probably going to see a lot of cool stuff. But you can download Vizzcode now for free. Get started for free, right? And then just start learning this way. It's going to be way easier. It's going to be way easier. So let me delete these guys and start over again. So we imported a library, which is a lot of procedures, right? There are, not a lot, a couple of procedures there to print to the method, to print to the user. I closed what Dandy showed, but I have to print with that crazy machine, right? And then I'm going to execute this main method, the entry point. So the entry point is going to be these commands. Which commands? Well, let's print. Let's show a message to the user. Let's show hello Vizzcoder. Because now you guys are Vizzcoders. You guys are programming. And if I compile and run, there you have it. This is, well, we already ran a couple times, but this is one of the first programs that you created. Hopefully it's going to be the first one of many, right? And hopefully that was easy and you managed to grasp. But if there were a couple things that you really struggled with, like it was asked, you maybe just keep practicing a little bit. And to help you practice, I'm going to link you guys to the programming exercises. So if you go to Vizzcode.com, then you go to Learning and Support Documentation. There's programming exercises here on the left. And there's like explanations of how to use this hub and like some tips about problem solving that we're going to talk about a little bit. But then there are like the real exercises here. And the thing about exercises is that just like being strong, like getting strong physically, you need to put a lot of time and effort in it, like no pain, no gain kind of stuff. But in terms of programming, practice is the most important part of learning how to apply the concepts. That's perfect. So Dandy kind of was very, very precise when he said that, because if you don't practice what we just discussed, and we discussed a lot of stuff, really. We discussed about importing things and printing and typing with the quotation marks, things like that, and maybe even typing text here like print, like we did. If you don't practice that before trying to learn things, anything else, you're probably not going to fit the whole thing inside your head. And it's going to get complicated, this video. So what I am going to suggest for you guys is, if you're following along at home, stop the video right now and go to the documentation and do these two exercises. So there's the hello there, and there's the roses are red exercises. So you're going to do, the cool thing about these exercises, that first of all, you're just going to see like what you must do, like print a program, makes a program that prints the following message. But then there are several hints that are going to incrementally give you more about the answer. So if you're not sure how to proceed at all, you're going to see hint 1, like, remember, you need to create a project, create the entry point, import the print library, and call the print procedure. So now it's specified what I have to do. So good, so now maybe I'm going to import the library, but I don't remember specifically, maybe I can follow these links. But then hint 2 is going to give you a link to a more detailed tutorial, and so on. So as you go through the whole, and then you have the final answer here. So as you go through the hints, you're actually going to have more and more of an understanding. And maybe you don't want to do any hints, which is good, right, for your brain. But the hints are great even if you read them afterwards, because there are some pretty cool tips there. So the same thing for this other program. So I'm going to leave you guys to pause the video and go there, right, while I drink a little bit of water, and solve these exercises. Then I'm going to learn new things. Do you actually work as a programmer? How long have you been coding? Yeah, I don't know. I've been kind of programming for a long time. Like, I programmed a little bit in Flash with ActionScript, and then, like I said, I learned C, but I actually didn't program anything. I started doing real programs when I was 17. I was doing a video game. I can show you guys, right? I created this video game, released that on Steam and on PS4. But yeah, that was pretty cool. I didn't create it alone, by the way, and I used the game engine for that. We're going to talk about that later on in the end of the course. But the thing is, I was learning as I went along. Could you give some brief inspiration by showing some of the later projects we may go exciting? Okay, yeah. So that's a good point, Andy. We are creating these programs like roses are red, violets are blue, the computer thinks in binary, and so do you kind of programs, right? that poem's perfect. That's art right there. But these concepts, like I said, must be practiced, right? Because once you have an understanding of them, first of all, in Vizzcode, right off the bat, you're going to be able to create cool games with it. Like, these are the games that I created with it really quickly, just to give a feel for the language, like show the capabilities. So this is kind of a Flappy Birds kind of game. It's like invaders that you can move around. There are like particle systems. There's sound. I don't know if you guys can hear, right? But there's sound going on, music, sound effects. This one's pretty cool. We have a limited timing score. And all these tutorials and all these games are in tutorials as well. So that's what you can do, like right off the bat. Once you understand what I'm going to teach you guys in this course and practice, right? Have to practice. You'll be able to start following more and more advanced stuff. In Vizzcode, you can do this like pretty much after you understand these exercises that we're going to do, right? And after that, then you can follow your own passions. Like I said at the very beginning, it's great because programming is about giving life to your imagination. So if you have a crazy idea about a program, you'll be able to apply that. And things like this is really cool because it's interactive, it's fun, it's engaging. And that's why I love programming games, for instance. That's pretty cool. So those are the kinds of things that you'll be able to build. And of course, like I said, you'll be able to build rockets and cars and websites and apps and robots. Those are all possibilities that programming gives you. And by starting with these small steps, and hopefully it's going to be easy for you to get these first steps, you'll be able to apply those lessons. How many lessons are there between print and Flappy Planes? Okay, so in terms of tutorial, which is I suppose the main count of lesson, I suppose, there's the introduction, which we're going to cover in this course. This course is the whole introduction. This is the complete introduction. So in terms of tutorials, there are 9 parts. But if you're watching this video, you can see the whole thing and work through the exercises. So the exercises are tangents. I don't know how to say that. They're kind of they're real time. So we must do them at once. So the introduction and the exercises to practice, right? And then when you finish learning the concepts that we are going to learn in this video, then you can jump right in. And not today, because this video is going to be pretty long. but the concepts will be applied immediately. So you can go to the tutorials and start right after you understand what I'm going to teach you today. Or you can search for more tutorials on that on my YouTube channel or Vizzcode or here in the documentation and start programming that. So it's not really that far. That's an interesting thing. You can really get started quickly, especially if you practice. So if you practice this a little bit about the print that we've been seeing and understand that, then you can start doing some more interesting things, which is getting the user to talk back to the computer. So that's the thing. Because as you can see, like in a video game, tangential, okay. That's a hard word for me to say. In Portuguese, we don't have that kind of a tangential. Sounds weird. Okay. So as you can see in video games, not only a lot of stuff is happening, so instead of printing messages, it's actually displaying graphics and animations and particles and stuff. And well, also text, right? But cool looking text. There's also user inputting data. So that's a key thing. So our program becomes a data transformation, like we said before, of the user's data, which is the input, like maybe text or maybe the mouse and keyboard or maybe a joystick in a video game. And then we transform that through some crazy operations into something the user can see. So that's what we're going to start doing now. We're going to work with text because that's what we are using so far. But instead of doing the print library that displays, I'm going to call the I/O library. I/O in this case means for input, output. So everything we could do with the print library, we can do with the I/O as well. So there's that. So we can print messages, things like that. But we can also read input from the user. And that's a great thing to create in terms of like programming. Because now our programs become interactive, which is awesome. Like if I drop here and see the possibilities, not only do I have the print, like I said before, I have the print and these other ones that we already had. Now I have this scan and scan in function. I'm not sure what that is, so I'm gonna explain to you guys first. But the basic idea is now a command is going to be like, instead of just telling the user stuff, it's going to be read things from the user. But if you guys remember, you guys have to remember, right? It's not been that long, just like an hour. If you guys remember here, in a computer, there are two main things that we need to worry about now, which is the CPU, the processor, right? That processes the data, that works through the instructions, right? And the memory. So if we ask the processor to read something from the user, where is it going to store it? It's going to store it in the memory of the computer. So now it's going to be a good time to tell you guys a little bit more about the memory, because I drew this diagram here. Let me see about the CPU. Ask it to store things in memory 6 in position 0, and then store another thing, and then add things. Now we're going to do this exact same thing with user data. And for that, we're going to use a concept called variables. So variables are awesome. They are a construct of the programming language, right, that allows you to easily create pieces of memory that you can use and store values in it, operate on these values. It's awesome. So a variable is a piece of memory for you to operate, like this square leg here. The best analogy I can think of is a gym locker. So imagine if you're like in a locker room inside a gym. I'm going to try to draw that maybe in perspective just for me to fail miserably. Yeah, that was pretty bad. Okay, maybe not in perspective. Okay, so you can imagine a series of lockers. That's the computer memory, like I just drew here. The series of spaces, right, for information to be stored. And each locker, of course, has a number, right? So this is like locker number 0 and 1 and 2 and whatever. And just like in the gym, you can place your belongings inside the locker. And then when you store your belongings inside the locker, then you can pick them up later on, right? Same thing, and the locks are mutexes for multi-threading. Oh my god, I shouldn't have said that. That was going to be crazy. Yeah, maybe locks. Yeah, but for beginners, locks I think are a good analogy. But yeah, I saw what you did there, Dandy. Very, very witty of you. Okay. So with these lockers, we can actually place information inside of them, like we did here, then retrieve this information. So if I say that this variable, let's say variable 0 here, let's say that's equal to 6, like we did before, and 1 is equal to 10, we can then say that variable 2 is equal to something like the value inside the locker 0 plus the value inside locker 1, for example, like we did before. So we can express these ideas of memory through, hello, how are you doing? How are you doing? We can express these ideas of memory through variables. And the good thing about variables is that they can be named. So instead of just referring to them with our numbers, exactly, we put labels. Good point, Dandy. So instead of just saying like 0 and 1 like we did here, we're going to name these pieces of memory. Like this guy is going to be called, I don't know, first number, and this one's going to be sec num. I will make my own game thanks to you. Dude, that's awesome. You know, maybe you can send me your game. that'll be awesome. Yeah, I'd love to see that. It's really cool. And maybe play it. That'd be cool. So yeah, you can name these pieces of memory and refer to them by the name. And that's going to be really useful. So let's go back. No one's in the stream chat for your game. Well, there are people in the stream chat. You just arrived, and we were having some good discussions about mutexes. Okay, so if I drag off here, I'm going to see in the very, Steam, not stream. Okay, so I read that very quickly. I mean, no one is in the Steam chat for your game. That's true enough. But, you know, in time, everything needs time. Well, let me open the window a little bit. It's kind of hot here. Okay, so I'm going to create a new variable here. And as you can see, it's a new node, just like we did before, right? And there's a name, just like I said, and then you remembered that we can and should like name these variables, because it's going to be really easy for us to refer to those pieces of memory. Like var here is the name of our variable. Maybe I can call that, I don't know, number. I'll call that number. And the type here is set to auto. What does that mean? Well, if you imagine a gym locker room, maybe there are like small lockers and really big lockers, and then there's like a series of lockers that are of the same size. They're not always the same. That's because some people have more belongings than other ones. Some people like, go into the gym with all sorts of crazy stuff. So people need to store things of different sizes. And similar to this, our memory, our variables, can subdivide the memory in pieces of different sizes. For example, maybe this part of the memory is pretty big, and maybe I can hold a text like here, like hello. So this first variable and second variable are holding numbers, right? But this other variable is holding a piece of text. This is what I mean by the type of the variable. Is what is it holding? For example, numbers or text. Auto means that, well, whenever I type here or connect here, it's going to automatically find out the type. So I just typed 0, which means a number. If I type like 1, 2, 3, that's a number as well. If I see here, I can see all the types that we can play around in Vizzcode. And those types, they kind of look weird for you, like int, float, string, but what does that mean? Those types you're going to see in most programming languages. So that's something good to be familiar with. But auto is a good one when you're not entirely sure, or just kind of want to quickly get started. Numbers like we're typing now, whole numbers, integer numbers, they are ints, right? Int's the short of integer, whole number. So I can just type like 1, 2, 3, that's an integer number. Similarly, there are float, which means are floating point numbers. I'm not going to go into detail of why is it called floating point. You can just picture that a printer that Dandy showed, as in there is a pretty good explanation for that, but one that you don't have to really worry about that for now. But in this scenario, I can type like 1, 2, 3 dot 1, 2, 3, and I can actually compile the program. If I try adding an integer number and doing like 123.123 and try to compile, there's going to be an error, like we saw before, like expression evaluates to a different type in this node. I wanted int and found float, because you said it was an int, right? But you gave it a float, so that's an error. This means that it's type safe. by having a type-safe language like C or C++ or Vizzcode, it's really useful for you to not worry about conflicts in operating data, like we're going to see in a while. Because when you operate data, you want to operate on data of the same type, like adding two numbers. I'm not going to add a number in a text. That doesn't make sense, right? So by having a strong type of data in the variables, you'll be able to easily work with that. So a string, and we're not going to talk about that for now. We're going to wait for that in another moment, but in this course still. But a string is a text message. So before, when we did the print, you can see that's actually pink, like this. It means that the type of the expression that it accepts is string. Like if I change to float, it's going to be blue, and int's going to be green, and so on. So these are the same type. So print, I'm going to print a message of type string. So if I type something like hello, what I'm doing here, floating point, because that's, I'm not going to get into that, Danny, because I think it's easier just to say that floating points, floats are like real numbers. And I think that'll be easier for beginners to get to the, maybe you can understand why it's called floating point later on. But and the other ways to store real numbers and things like that. Okay, so the thing is, when we created this node, we are declaring a variable, like I said here. We're saying, okay, there's a locker. Let's say it's this locker. There's a locker that I'm going to refer to by the name number. Well, it's not number anymore. I'm going to call that var for a variable. That I'm going to refer to with the name var. And this locker is going to have the data hello, the text data hello. So hello, I'm not going to fit that. Okay? So that's what happens when we create a variable. And just like before, not hello, let's say Vizzcode, because hello is right here. So, okay, so now we can refer to this message. Now I can, it's going to be Vizzcode, VZ. Now you can refer to this data whenever you need, just by using the name var. For example, here in the print, I could type a message here, like I showed you guys, like hello. And then I could compile that and run hello. But I could also use this pin, this expression pin, to connect a variable. See that this var here is the variable that we created here. So if I select it, what's doing is, well, when the program starts, give me a locker that holds text and put Vizzcode, the message Vizzcode inside of it, right? And then you should print to the user whatever is inside the variable. And what's inside the variable? What's inside the variable, guys? If I press run, what am I going to see? I'm going to see Vizzcode. Okay, because that was what that is what is inside the variable. Wow, that was kind of hard to say. Okay, so if I type another message here and I compile and run, I'm going to see another message. Why is there a little grid next to the type dropdown? Oh, yes, good point. So very observant of you. So here you can see this guy, and if I press this, it's going to be a variable of a special kind of variable that we're going to see in a while. Okay, so yeah, that's pretty cool. You can see those are pretty cool. Yeah, it's about data structures. That is about how you can structure these guys that we are seeing. Okay, these guys. Okay, yeah. Okay, cool. So I think you guys understood about variables, right? So we reserved a piece of memory that we're going to refer to by name var. Imagine a locker. Now this locker is here, and right now we're putting inside this locker the message, another message, and then we're going to print whatever is inside the locker var, like this. Perfect, right? Clever, yeah, thanks. Well, that was kind of very inspired by Unreal's way, this kind of icon here. It's not mine, kind of I was the first one to come up with it. I am going to show you guys, again, going to the text mode, how I'm going to print the variable again. If you note how it was created, it's like var, and then there's like a colon, and then an equals, and then the thing. Well, that is in this language how you're going to declare variables. right? And we are going to see different ways of doing that later on. But this syntax here is going to be different depending on the language that you wish to learn. But the idea of creating a piece of memory, calling it by a name, and then assigning values to it, then using it, it's going to be the same no matter the language you use. So that's the important concept to take away, right? Right here, I'm going to call print var again. I'm going to just copy the line I did, and then I'm going to create another one, right? So, I'm going to also add the \n so I can break the line. So, I'm going to print another message, right? But the name variable implies a very interesting behavior, is that the value can change, right? It's not like a constant value or a static value or whatever. I can change what's inside of it, just like the locker. Like I placed Vizzcode inside the locker, or now it's like another message, right? I'm changing those too fast. But I can take that away and put another thing inside here. Let's say I put hello back. Okay? So that's what we're going to do now. And we're going to do that with a very cool node called set. I don't know if you guys can read that. Set. And there's an equals here because the way you're going to see that in text code is with the equals. So if I press the set node, just a thing, you may be wondering, well, it wasn't here before. That's because there's this contextual filter here, which means that most of the nodes are not being shown because they don't make sense in the context that you're trying to create them. Like if I try to pull from this node, I'm not going to see a set, which are going to see new nodes. You can turn that off to see all the nodes that you have at your disposal. But let's create the set node. And the set node receives two things, as you can see. First one is variable, second one is value. So like here, we declare the variable, but we also set its value. As you can see, we typed a message, and that message was inside the variable. So if I select here a var, which is the variable I want to set, and set it to, let's say, hello, what's going to happen is I'm reserving a piece of memory and assigning the value another message. Let me drink a little bit more water. And then I'm going to print the message, var, the message that's inside of var, which is another message. And I'm going to set the value of var to hello. So it doesn't matter what was there before. Now I'm putting it hello there. It overrides what was before. And then I'm going to print what's inside again. As you can see, the print's the same. The print is print what's inside var. Okay, but the difference is in the middle of them, I am setting it to a different value. If I copy some code from the internet and paste, will it run? It would if it's in this language. So, for example, if I go back to the documentation, and let me see some code. This code. I can just paste this code here, and see, generated the nodes for you. So it is going to work. But if you paste a code that's in another programming language, like we saw before, it's not going to work. You have to program in Vizzcode's language when you're inside Vizzcode. But hopefully, there'll be enough examples and exercises inside of the documentation that you can copy a lot of cool stuff, including games. So the games has lots of pieces of code that you can copy and use it to use. But if you are in a different language, you may want to alter that a little bit. Like in a procedure, maybe instead of doing like main equal colon like this, like we're doing, maybe if you copy from, I don't know, C, it would be like this or like this. So it really depends on the programming language. So, but in order for it to work in Vizzcode, it has to be in Vizzcode language. Okay, so let me quickly go back. What is the backing language for this? I'm not sure what you mean by backing language. You are going to program in this language, so the visual and the text at the same time, right? And when you compile, it generates machine language. So you don't have to worry about that. All you have to know is that what is the programming language? Yeah, so inside of Vizzcode, you're going to program in this language. So it's a new language, Vizzcode's language, right? Which is visual and textual. So you're not going to see a lot of things. Yeah, it's a custom language, exactly. That's the word I was looking for. It's a custom language inside that you're going to program with. But the thing about this language is that since it's based on a lot of mainstream languages like C and JavaScript and Python and Pascal even, it's going to be really easy to transition to a new language. And that's the greatest takeaway. Vizlang Yeah, I thought about Viz, just Viz. The file is .viz. Vizlang, it's pretty cool, I think. I think I liked it. So the idea, like we were discussing, of creating variables, this is going to be transitioned to whatever language that you use, no matter the language. You are going to do it differently from this syntax, but the idea is what's important. So that's what I want you guys to take away from this video and using Vizzcode, is that learn the concepts. Even when you get to game programming, that we are going to use a few tools to help us, like how to draw images on the screen, things like that. So even though we are using tools, the main focus of Vizzcode is for you to understand the fundamental concepts of programming, of, you know, giving instructions for the computer to execute. Once you understand that, the language kind of doesn't mean much, because once you learn kind of I don't know, the clothing, the skinning of the language, so to speak, the skin of the language, you can do the same thing, because it's all about specifying commands. How does it display complex structures like object-oriented stuff? Okay, because since this is a very VC, yeah, so we are going to have a VC Pi C++, like it's being suggested, but we are focused on very much like data-oriented. Like we're going to focus a lot on arrays. I'm gonna show you guys arrays later on. It was already hinted here, and we're going to organize data like this. But you're not going to be able to create like crazy stuff like linked lists and more complicated structures of programming yet inside Vizzcode. So the focus now is really learn the fundamentals and explore them however you want. So the tools that I'm teaching you in this course, you'll be able to use them like crazy to create all sorts of crazy stuff. And then you can add new language features like you're saying, like object-oriented stuff, or maybe like linked lists, which you can program in whatever language. Then you'll be able to add those on top of what you already know. So that's the main focus, on solid foundations and not very much features. And that's what I opened the course with. I was saying that this is not a very specific language tutorial about a specific language. Like, okay, so we're going to do like this in this language. And then I'm like, okay, but how do I do this in the other language? Like, I don't know. This is very language specific, but not in this case. I'm teaching you like the fundamental concept. So hopefully that'll be enough for you to really understand about programming. And that was one of the previous questions, were like, okay, I tried C++ and stuff, but that was too much. So this is kind of a pathway that's not going to have like crazy arbitrary stuff that you should probably use later on when you get better at it. This is going to be like a solid foundation that you are going to be able to create cool things with. It's not like, okay, just boring stuff. You are going to be able to create games and very interactive pieces of software with it, like complex marathon exercise, things like that. Okay, so if I go back to what we had before, which was like we were printing a message, hello, and then I called print var. See, so I was typing the text, but you can also do it here. And then I was setting. Oh, before I used the set like this, I connected the node var to here. I could also type var here. It also works. Like if I set hello and then hi, and I'm going to add the \n to break the line here. It also works. It's the same thing. Var equals hi. It's the same thing as connecting var here. Oops, well, deleted this guy. And I can also do it here. So you can also type expressions here. It's pretty powerful. And then I'm going to print the value of var again. So what do you guys expect to see? Right? Again, I'm reserving a piece of memory like a gym locker. I'm opening a gym locker that I labeled var, and I'm putting the message hello inside. Then I'm printing whatever's inside of it. Then I'm setting, again, hello \n, hi. Yeah, so the Andy is right. We are going to get this. So because we're going to print what's inside, right now it's going to print hello, and then I'm going to change the message. Then when I print what's inside, it's going to be another message. So hello, hi. And this is interesting because like we talked in the very beginning, the sequence of instructions, the order of the instructions really matter in the sequence, right? Because if we were to like print before setting it again, like this, we would have like hello, hello, and then we set it to var, right? So this is the kind of thing that you want to be wary of. So let me just reorder these guys here. Of like, you have to really know step by step what the program is executing. Okay? I think you guys understood that, right? Okay, but now I'm going to kind of combine two things that we talked about. Someone stole the value hello out of your locker and replaced it with cheap hi. Exactly. So I'm not sure that was a very good trade, right? Hello is much more, I don't know, so it's more interesting. I was trying to look for a fancy word, Maybe I just use fancy. It's much more fancy, much fancier than hi. Hi is just, maybe we can talk like, this is a long message, right? And another S. So yeah, now I think it's a better trade. Okay. Okay, but like we said, what happens if I put emoji into it? Well, you know, it's not going to display. Well, let me try. I'm going to copy the emoji. I'm not, what's going to happen? I'm not even sure. Yeah, if I, it's going to be like this guy. Maybe I could search for like a real emoji. The whole sentence, yeah. It's not going to display the thing. And depending on the console, like when I press run, it's using Windows default. Okay, so Dandy sent an emoji just for us to break the whole thing and crash the program and be destroyed, right? So yeah, so I can't see the emoji, but it's there, right? It's not displayed, but it's here. If I go to like Notepad, oh, Notepad does display it. Wow, I'm surprised. But if I try to compile and run, the Windows, Windows console doesn't support. This is like sending the emoji encoded in UTF-8. This is like some crazy stuff about character encoding. It doesn't read it. If you're supposed to use a program to read this, automated by Notepad. Dude, you are right. I was. That was pretty shameful. But if you probably use a command prompt that has support for UTF-8 characters, maybe it's gonna work. But yeah. But at this point, you should probably use like graphical application like this one, and then you can add not only emojis but also animated emojis. How about that? There's no animated emojis in the chat, right? I don't know. We're probably gonna outsmart me and show me an animated emoji. Okay. Pretty cool. I think you guys got that, right? I'm gonna show you guys combine two things that we learned. Really awesome and innovative. Nobody has thought of doing this like Vizzcode till now. It's just crazy. Yeah, that's a pretty interesting thing because there are interesting things. Well, we have some Unicode support, Dandy. Like if we type like, see, let me show you guys here. That's easier. This, it works. Even like crazier stuff. I don't know how to do crazy stuff in my keyboard, but we support some crazy stuff, especially because also it's in Portuguese. Oh, I should have mentioned that before. Like, you can change the language here, and then like you're gonna have like início do escopo global, things like that. Biblioteca instead of library. Parameters like become parameters, right? Only Portuguese is in English for now, and the whole docs is also in Portuguese. So, yeah, it's actually a custom extension to Unicode. So I added some random characters. Like there are some pretty crazy characters that I added, like some crazy dollar signs and stuff. But yeah, basically just for like Latin support. Yeah, for now. No, we're not gonna have Chinese characters. Yeah, so he pasted some Chinese. We're not gonna have them. Yeah. Yeah, but that's a good thing to add later on for more internationalization, right? So, okay, back in English, I'm gonna show you guys combine two. Do you plan to translate the tutorials? Yeah, everything that we have so far in Vizzcode is in Portuguese and is in English. So we have these both languages in it. It's pretty cool. In the docs as well, like even like big things like, I don't know, the expressions page is pretty big. So there's this like whole thing about expressions and with full of images and stuff. The whole thing, you can change that to Portuguese. And even the images will be the same, different, like this is chip float, right? And parâmetros, retornos, things like that. Instead of set, is atribuir. And as you can imagine, it was a lot of work. So these are the two languages that we support for now. But hopefully, the more people use Vizzcode, the more cool languages we can add. That'd be pretty cool. It's way easier to learn, especially if you're younger, if it's in a native language, right? Okay, so what I want to show you guys is that, like I said, we have these different, let me just delete these guys. We have the different types, right? Oh, we were actually supposed to read messages. Oh my god, I got so sidetracked. We are going to get to the cool stuff. But let me first, I imported I/O, input, output, to show you guys how to read input, how to receive messages. So instead of just typing a value of the variable here, this is called a hard-coded value or a literal value because I'm literally just typing the code. Instead of just typing that, I'm going to pull the spin off, and then I can call the procedure scan. So for now, we've been calling print, and then we can pass stuff to it, like the message. But now if I pass it like to the left here and call scan, as you can see, scan is actually giving me a value that I can connect to this variable. Also const versus variable point. Yeah, I'm not going to point out that now because it's a little bit confusing and not all languages support that. So for the sake of like beginner introduction, let's just say you can just like specify things in the memory through variables. And then, okay, yeah, it means that it doesn't change. Yeah, that's a good point. But if you specify like a variable and put some value into it, a value like this, right? Yeah, they're opposites. Yeah, you can change later on. Let's just focus on that for now. But I see what you're getting at, and that's a good point for later, I suppose. Okay, so the point is, when you call the scan, it also receives a message. So I can type a message here, like type your name. Oh, I just changed my keyboard layout to Portuguese. So type your name, back to English. Okay, so this is the message that I'm passing to scan. But scan gives me a value. Then right now I am assigning to the variable var. This is how it looks in text. What it means is that when I try to scan, and scan means that I'm going to read the whole line the user types. And if I scan the line, right, there's the input, that's what the user typed. If I scan the line, the result of what the user typed is going to be stored in this variable. How do we know that? Well, that's right, printing it. Do we know how to print variables? Maybe you can pause the video and try to print it yourself, right? But it shouldn't be too hard. You can just drag off here and go to print, and then drag off here and go to var. So just to recap, I'm creating a variable, so it's a piece of memory that's going to store a text. And what's the value that I'm going to store there? It's going to be the result, the return of the scan procedure. It's going to read what the user types. So the user is going to type, I'm going to store that, then I'm going to print the result of the variable. So that's right, compiling and running. What's your name? Let's call Dan. That's my name. So it says Dan. Pretty cool, right? So what we have here is the beginning of an interaction. Like the computer is telling me stuff, then I'm telling it stuff, and then it's telling me stuff back. Right? Maybe we can format a little bit, like we can add another print and be like, your name is Dan. So type your name, Dan. Your name is Dan. So we learned these two commands and also creating a variable, right? But like to scan and to print. And this is already powerful enough to start playing around. Like, for example, I have what's your name? Your name is. Maybe I'm going to create a new variable. I'm going to call age. Can you make it so you convert Fahrenheit to Celsius? That's a good point. Let's try doing that, actually. So a suggestion was, let's make a program. That's kind of our first real-world program, to be honest, that converts Fahrenheit to Celsius. That may be tricky. Let me get the formula here. Fahrenheit to Celsius. Is that going to involve? Yeah. Do you know the formula off the top of your head? While I search it here. Okay, so this is it. So let me just type that for you guys to see. So this is the formula. So Fahrenheit is Celsius times 2 plus 30. So you guys are starting to think about something else because we are learning how to read inputs from the user. And that's an approximation. Okay, so I think we're going to do that because it might not be precise enough. Yeah. But it's probably going to work for us. Yeah, it's going to be like approximately. Is it like this? Yeah. It's 5. Yeah, so it's supposed to be 32. So this is the correct formula. We're going to work with this one because it's going to be way easier, I suppose, for new people. But let me say with the caveat of not correct. Okay, not correct, not entirely correct. So I'm gonna do this version. That's going to be a little bit easier, I suppose. Maybe meters to kilometers. Okay, meters to kilometers is easy. Meters to kilometers, or kilometers to meters. It's going to be easier still. Oh, you guys can see that. Kilometers to meters. So let's do a program that transforms kilometers to meters. And as you guys probably know, 1 kilometer is equal to 1,000 meters. Okay? So we can already extrapolate a simpler formula like meters equals to, well, we can do like kilometers. Yeah, well, we're going to get to that. So, yeah, for easy math, it's too easy. You can just print 3 zeros after it. Okay, so we're going to do 2 ways. You guys are getting way ahead of yourselves. But first of all, let's do the cheap way, adding 3 zeros after it. Then you can do some crazy stuff. Because like I said, we can use scan to type a message. The user entered, right? But if you remember correctly, the type means what kind of value it holds. And scan, as you can see, it's thing, right? It's a text message, and we can't do arithmetic in text. For that, we need another kind. Let's say int. Okay. So, for example, if we let's say age, if we have the age, and then we call scan int, because scan's not gonna work. If I try calling scan, it's not gonna connect because it's of a different type. But if I call scan int, it works the same way. I'm gonna pass a message like type your age, your game. I don't know why I have game in my head because we're seeing the games that you can do with Vizzcode. Type your age, same thing. So type your age, say 23. That's the end. But like we said, we're gonna print. But if you try to print the age like this, like we did before, it's not even gonna show up the age here because we can't it's expecting a string, so we can't pass a int to it. So we're gonna use the print int procedure, okay? And then we can press the age. So it's just the same thing that we did before, where we are reading type your age, we're reading a command, and then we're storing that in a variable and then outputting it. So like we said, when the variable is in the memory, you can do whatever you want, you can output, but now we're going to learn how to do operations on it, because that's the basic structure of the program. Let me show you guys. So we're talking about the CPU and the variable and transforming data. When you talk about transforming data, let me draw it. So like when you talk about transforming data, which is pretty much what programming is, we are going to see a pattern of input, processing, and output. Okay, we already learned how to read data, so how to handle input with the scan, for example. And if you think about games, for example, this part would be getting if the user pressed a button or not on the gamepad, or clicked the mouse button, or what he used in the, I don't know, whatever input device he's using. Maybe it's a telephone game, a phone game, and it's using the touchscreen. So that's all the input. So the user interacts with the program. But then the program processes some things. Maybe it could be just like transforming meters to kilometers, like we said, it was pretty easy. We're gonna do a slightly harder. We're gonna do like, you say your age to year of birth. That's gonna be cool. So you're gonna say your age, then I'm gonna give you the year you was born. Okay, so we're gonna process that input somehow. It could be like doing some math operations, like we were talking about before. It could be doing more complex transformations, like in a game, we're going to do collision tests and like see if the user shot the enemy and if the explosion happened and all that stuff. And in the end, we're going to display the result of those operations. Maybe it'll be an image called a frame in the game, or maybe it will be just like a text that we're doing. And for now, we're going to use print to output and scan to input. And the processing is gonna, we have all sorts of crazy stuff in our tool belt, so to speak, to do processing. One of the stuff is arithmetic. For example, if we have the number age, we already know about the set. node, right? We're gonna set, let's say, we're gonna set age to 10 again, let's say. So the user types his age, we print the age, and then we set it to 10. That's just an example, okay? But that's not very exciting. And then let's print again. Okay, that's not very exciting. Oh, as you can see, the nodes move around here. That's the same as clicking arrange nodes. So arrange nodes kind of help you organize the program a little bit, especially for bigger programs and stuff. I'm also going to save. Okay, so that's what's going to happen. Again, I encourage you to pause and kind of think in your head what's going to happen. Try reading the code and try reading the visual programs. Like, what is going to be the output? Like the age, I'm going to scan, I'm going to type the age, then I'm going to print the age, I'm going to set the age to 10, then I'm going to print the age. So what do you expect if I say like 23, it's going to be 23 and then 10? Well, I should probably add a new line there. I don't know if you guys can see. It becomes like 2310. That's no good. Let me print a new line. So, okay, so that's better. Okay? But this 10 here is just setting a new value. What kinds of interesting stuff? What happens if you type 20? Good question. If I type 20, it's going to be 0. But I don't know if you guys saw. If I add like a scan node here, it's going to be just the value. But a scan int has the value and a success pin here, which I don't know, I can't connect, I'm not sure what's going on. We're going to talk about that later on. But this makes sure that the user actually typed a number, because this is the thing about users, and that's an interesting thing to learn in this Intro to Programming course, is that your program transforms data, right? So it expects the data to be of a certain format, or a kind, or a type. And the user doesn't necessarily know that, or care about that, or maybe there's a error in the beginning and in the middle of the way, and data of unexpected formats will go through your program. And part of creating a robust program is dealing with unwanted data in a pleasant way for the user. For example, in this program, okay, so I have to delete this unconnected node. In this program, if I type like crazy stuff here, it's going to be 0. Is that what I really wanted? Or maybe I wanted like a message, like wrong type erase potato. Yeah. Is that what I really wanted? And what's the user going to see? And I actually talk about that in depth in the programming. Oh, I changed that to Portuguese. In the programming exercises, there's a couple of very, very cool notes. Well, I suggest you really go through these guys, because there are a lot of good info here. Like handling errors, like if I search for handling errors, yeah, there's another, someplace else, where I talk about this thing about handling errors in a good way for the user, right? And this is where it comes in, like what happens if you test, if I ask, documentation is in Portuguese, yes, it's in Portuguese, and, oh, it was in Portuguese? Dude, I didn't even see that. Oh my god. I'm so focused on kind of a talking that I didn't even see that, so thanks for the heads up. Yeah, okay, but now what we want to do is not simply set that to a number like we were doing. We did that a lot, right? We are going to set that to an operation. If I go back to the context filter, you can see things like add, subtract, multiply, divide, and other crazy stuff. So let's add this add guy. Let's do like 10 plus 5. And see how that is represented in the visual panel, in the text panel. It's 10 plus 5. Just like we saw in the formula, it was like 9 divided by 5 plus something like in parentheses. Similar to what you see in math, like this is the formula that you guys were talking about. The, 32. Talking about, when talking about math, right? You're going to use a very similar way to represent arithmetic operations and other kinds of operations, right, in programming. So this 10 plus 5 here, represented in this node, well, you could add a node, or you could just type the operation here as well. It's the same thing. So I could do like this, add 10 plus 5, or I could just like do the 10 plus 5 like this. Okay, it's the same thing. The computer is then going to operate on this. It's going to do this operation and then show me the result. It's going to set to the variable the result of 10 plus 5. It's going to set the value 15 to the age. So now we're going to see 10, 15. Okay? And let me just go back to this example here of 10 and 5. Another thing that you may want to try around, and I wanted to encourage you guys to try around things like, for example, you see that this node here, it's similar to nodes that we've been using like printing values and stuff. What happens if I put the age variable here? So right now I am setting to the age the value of age plus 5. Look at the text representation. Age equals, so it means I'm setting the value to age. It's going to be age plus 5. So let's say I type 10. It's going to be 15. Why? Because first of all, I print the value that I received. So 10, I print 10 here, right? Then I set to age, to the value of whatever is inside age, what's inside age, 10. Then I add that to 5, so it's 15. And then I set that 15 to the value. I am 10, okay. Yeah, I think we're going to do a program that actually can interpret everything that Dandy just said. That would be the hardcore challenge for this for this course. To support all the Unicode characters and all the binary operations. Okay, we're gonna get to that in a moment. Well, not to that, but to binary operations and Boolean and stuff. Okay, so with this, you can already start to see the possibilities. Like, what if I add another add here? And maybe 10 and 5. What do I see? Well, age plus 10 plus 5. Well, can I add another one and keep adding stuff? See? And it's really interesting because the way that you create expressions, this is called an expression, right? Like a math expression. But it could be, not only math stuff, but the way you create expressions, this way is represented here as well. So age is going to be, try to follow them both, right? It's going to be age plus, so it's going to be a age plus what? First of all, I'm going to do the 5 plus 5. So I'm going to 5 plus 5, add that to 5 again, then add that to age. So you're going to work from left to right. So I'm going to add 5 to 5, and add the result to 5. Then I'm going to add age to this guy. Okay, so it's going to be like age plus 15. So if I put like 15, it's going to be 30. You are free to create these crazy expressions. And like I said, you could add this whole thing like here. You could like do 5 plus 5 plus 5 as well. And this is also going to be represented here. Okay? So it's going to be the same thing. You may be wondering now a couple of things, because that was probably a bit too much for you guys at home, right? Let me explain a little bit more about what's going on. Like, first of all, what are these parentheses that are being created here? Well, if you guys remember from math class and stuff, there are certain order or precedence that operators take place. For example, I'm going to do this like in Notepad. I think it's easier. If I do like this operation, what is the result? Well, first of all, I'm going to solve the 3 times 3. So it's going to be 9. Oops, it's going to be 9. And then I'm going to solve the 5 plus 9. I can use parentheses in math to reorder these operations. Like if I had parentheses, it'd be like this. It's going to be now 8 times 3. Then it's going to be 24. See the huge difference because of the parentheses? Same thing in programming. The order, and there is an order precedence. You can check that out in documentation if you're interested in expressions. The order that you can see. What happens if you print? Oh, we don't support like the stuff. Oh, I don't know. Dandy's trying to break the program. Let's help him break the program. So he has us print this. So we didn't got the \p. Oh, okay, so it did work, I suppose. Yeah, so yeah, it's meant to be hello, yeah, but yeah. So this is gonna work just yeah, good one, man. So this is more like playing around with the console, like just like we did \n for breaking lines. The console, which is like this guy that you're gonna use for these kinds of programs in the beginning, have other I don't know, codes, I suppose. It's a decent word that you can use, like -b. The backspace is gonna go back one character. Things like that. That's gonna be pretty cool. that was fun. So same thing. If we set age to be, well, kind of weird that it's age now, but whatever. If we do that example that I did in Notepad, like 5 plus 3 times 3, then I print, I'm just going to go back just to age. So all I have now is age. Age is going to be 5 plus 3 times 3, and then I'm going to print the result. Or it should be number now. I'm going to call that number. Okay, and okay, it's open, have to close that. Okay, now as you can see, this is really clear what's going to happen, and you can see that even the parentheses were added. If I just remove them, it's going to be 5 plus 3 times 3. So first of all, I'm going to do the 3 times 3, which is 9. Then I'm going to add that to 5. Like we saw, it's going to be 14. 14. However, if I add the parentheses around here, look, oops, around here, look how the nodes are going to be changed. Now it's a multiplication node. It's going to multiply the result of 5 plus 3 to 3. So it's going to, first of all, we're going to do this operation, 15. Oh, 8. 8 times 3 is going to be 24. So we get 24. So it's interesting to see how these operations can be combined in interesting ways. Now, the first thing we're going to do is we're going to go back to age. And we're going to do the following program. We're going to read the age of the user. So the user is going to type its age. And then we're going to tell it, so the output is going to be the year the user was born. So now we're going to do the whole thing. We're going to read input, we're going to process it, we're going to output a different information. We're going to transform data. The data is going to be in a format of age, and then we're going to return the format year of birth. Okay? Does that make sense? You guys can just follow along, and then we're going to do some exercises together later on. Okay? So let's go to age, not page. And same thing, we're going to do the, I'm going to add that to scanInt. I'm going to type your age. Again, I'm adding a locker, saying, okay, this locker I'm going to refer to with the name, by the name of age, and then I am going to simply set the value to whatever the user typed, a number, right? I'm going to print that value just for now, just to see 23, 23, perfect. Now, what I want to do now is create another variable called year of birth. And as you can see, I'm typing these underscores here. That's because you can't add space here in the oh, thank you. You can't actually add space here in the variable name. And there's a lot of little rules, like you can't start with letters, you can't start with numbers, you can't have spaces, you can't have non-ASCII characters, things like that. For now, all I have to know is that if you don't have spaces, people come up with different solutions for adding more complex words. Like you're going to see this format, and each of them have like snake case names and like camel case, Pascal case, things like that, some crazy names. Thing is, you're going to see variable names like this a lot. You're also going to see names like this, where the first letter of each new word is capitalized, year of birth, like this. So different programmers and different companies have different styles for naming variables and identifiers, things like that. For now, I'm going to use this style. So I'm going to create a new variable called year of birth. And do you guys know how to calculate the year of birth based on the age? Let's say I'm 23. Can you guys tell me what year I was born? Okay, maybe you guys told me. I'm telling you guys at home, right? To get a current year, exactly. So what I'm going to do, I'm going to do a subtraction of the current year, which is 2020, in this case. I'm going to subtract 2020 to the age. So I'm going to create a new variable of type auto. So whatever this expression resolves to, it's going to be the type of this variable. We know is int. Can you get the actual, oh, we don't have a library for getting current year and stuff. That's a good idea, Danny, for like interfacing with the OS and stuff. That's a good idea to create these kinds of programs. May actually add that to the list. Okay. Sorry about that. My voice is already starting to fail. So only 2 hours in. I thought that's a hard part. Yeah. Dates are terrible. Yeah, well, I would just ask the OS for that. For now, I'm just going to type 2020 for this exercise, right? So let's say I'm 23, so it's going to be 2020. I'm going to get the calculator here for you guys to see. 2020 minus 23. We're going to have, well, it's not actually the year I was born because I haven't actually, my birthday hasn't really happened this year yet. So there is this problem, right? So there's a 1 year off in terms of like the answer, right? But the point is, it's going to give us a result of approximately what year he was born, right? That's the idea, 2020 minus the age. And then I'm going to print something like you were probably born in, and then I'm going to print int age. Oh, not age, year of birth. Okay, perfect. Okay, so let's just review what we've been creating. We're just experimenting by 1 error. Exactly. We're kind of used to it, right? So that's the basic idea. We're creating a variable that's going to receive the value of whatever integer number the user types. They want to print that number. Well, we don't need to print that number. But maybe we could do test, whatever. And then we're going to create a new variable in which the value will be 2020, which is the current year, minus the age. So we just worked out the math, so it may be approximately right. We're going to print the message, you were probably born in, then print the year of birth. Let's try the program. 23. Okay, so this is what we expected of the program to create. As you can see, this is like the basic idea. We're going to read input, and you may think that it's not okay, but that's kind of a simple program. But all programs really have this base structure, and this structure is kind of fractal. So inside the program, you're going to work with structures that are going to receive input, process it, and output. So your program, which is a big input, process, output mosaic, I suppose, it's made up of smaller structures of the same pattern. Okay, so what is fractal? Okay, so yeah, that was kind of an abstract vision. The idea was, yeah, I'm gonna draw in paint now. If we have like this big idea of processing, of input processing and output, IPO, let's call that IPO, of the program is going to be built of smaller structures, and the bigger the program, the more structures that look like this are going to be present in it. So it's going to be several structures that's going to receive data, process it, and return that data in a different format. So basically transforming data. So we pretty much got the first idea of a real program that actually does something useful. Well, kind of useful, right? Of reading a value, operating on it with arithmetic, like we saw, and then displaying the result. And just show you guys, like we were saying, we could also type the age here. And you could also type the whole expression here, like 2020 minus age. All these options are valid, and you're going to be able to experiment with them. I thought this was a program tutorial, not a web startup. A web business plan meeting. Dude, everything's a business plan meeting and a program tutorial at the same time. Think about that. That doesn't make any sense. Okay. What I want you guys to understand is because IPO leaked. Well, you guys buy the IPO. If you guys were to think about the possibilities of adding and subtracting stuff, I'm going to now challenge you to do another set of programming exercises. So in programming exercises, you can go to the processing, input processing and output. Okay, so these are the base ways to exercise what you learned. And as I said, you learned a lot of stuff, like read data, operate it, and display it. That's the basic idea. But the interesting thing, and that's the thing I love about programming, is that with these basic concepts, you are able to construct completely different programs that are very interesting and create very cool results. So that's great, I think. So I encourage you to pause the video and create and practice with these tutorials. And to be honest, they already start to get really interesting. You know, there are some really hard ones here, like seconds and minutes and days, hours, and stuff. We get to these kind of tutorials, which are pretty cool. And there's like an RPG combat system, which I give you a formula, which is similar to the formula that we've been playing around. Oh, another one you could do is like the Fahrenheit one that we discussed. Because now that you know how to do operations, you can combine them. Like, yeah, there's an addition and there's a multiplication, there's parentheses, things like that. And you can see like this one's going to execute first, and then this one, see? And there's a whole cool exercise about creating an RPG combat system. And these concepts that you guys are learning now are the base ideas that are going to use no matter the programming language and no matter the programming problem that you have. Okay, so that's the main takeaway. Okay, so with that in mind, I think we can move on to a new feature that you guys can learn. Okay, that are conditions. Easter egg, experienced programmers can change language to Portuguese in this website as an alternative to Duolingo. Okay, that would be cool. If you want to be extra challenged, you can set that to Portuguese and try to interpret what that means in terms of like processing, and then create your own programs while learning Portuguese. That could be an extra challenge for you guys. What's your name? See? Danny McD already got it. He already knows how to say what's your name in Portuguese. Qual é o seu nome? Agora. we need like a little like audio stuff so you can hear it as well. That would be pretty cool. Okay, now one important concept that we discussed is that execution of instructions is linear in terms that it always flows one to the other. Like sequential is the best word. The execution is always sequential. But you have a pretty powerful way to move around the instructions is by jumping around. Think about jumping around instructions. For example, I'm gonna draw like an abstract thing here. So let's say we have these instructions that we are executing, right? Instructions 0, 1, and 2, and 3. But now we're basically, okay, I'm not sure if I'm gonna do this or this other thing. Based on some condition, I'm gonna change what instructions I execute. For example, let's say I'm making a video game, and if the player explodes a red barrel, I'm going to play a sound effect. And if he doesn't, I'm not going to play that sound effect, right? So as you can see, that some instructions, like the instructions to play the sound effect, are only going to be executed on certain conditions. And that's a very important thing to understand. And this kind of a branching of the code, or conditionally executing, right, parts of the code, will allow us to really create powerful programs. Now, if you think we've been creating, I don't know, lots of possibilities with what we have now, be ready for this next one, okay? So, first of all, you need to understand about conditions. And conditions can work sort of like comparisons. For example, like I said, I said the red barrel, let me follow that example. If the player shoots the red barrel, so that's a condition right there. See, player shoot the red barrel. And it's going to be more elaborate, right? But for example, if I think about, well, if it's raining, I'll stay home and watch a movie. You can see that the condition, if it's raining, will be the base of some execution, like watching a movie. Same thing, like if I'm late, I'll go by car. If not, I'll go on foot. So right now the branching works two ways. So there's a true condition and there's a false condition. See? So if it's late, I'm going to go by car. If it's not, I'm going to go on foot. Perfect. Now, the thing to understand is that these conditions, they may be complicated, but they always return, or they always result to either true or false. For example, is it raining? Well, either it is or it isn't, right? Am I late? Well, depends on the time, I suppose, but if the current time, right, is, well, it depends on how much time, but the point is, if the time that you want to leave, let's say I want to leave like 11 a.m., if the current time, let's say it's 12 a.m., I can find a comparison, or like comparison is a good word, with these values to see that, well, should I leave or not? So the point is, these comparisons either result in true, yes, I'm late, or false, I'm not late. So that's the basic idea I want you guys to think, right? And this type of data, true or false, is what we call a bool or Boolean. Okay? And if I'm not mistaken, and I just going to say that so Danny can maybe correct me, Boolean is the name of the guy that formalized this concept. Was it not? The mathematician? I could be wrong, but I think that's right. I just threw it there just for fun. Don't quote me on that if that's not true. Okay? So let me go back to this example. And I'm going to say bool. So as you can see, when I change that to bool, the default value was false. And false is green here, which means that it's a keyword, or it's a literal value, right? It can also be true. So these are the only two conditions, the only two possible values that a Boolean variable can hold. Let's call that bool var. It's either true or false. I didn't know that. Yeah, I'm pretty sure. Oh, now I have to check that. Oh, Boolean. What is Boolean? Oh my god. Just so I don't give like super wrong information. Yeah, George Boole. Ha! Yes, he worked on Boolean logic. So yeah, George Boole, mathematician, exactly. So that was a true fact. Pretty fun. Yeah, I was pretty sure that was true. So, true or false? I said that. It was either true or false. No way around. I like this visualization for branching. Let me see. Dandy has probably as well. Okay, so he shows a pretty cool branching thing. So yeah, this is the condition, right? If this is set to this position, this is gonna go this way. Else is gonna go this way. So this idea of branching the code is dependent on a true or false statement. For example, this variable can be true or false. Okay, well, what good is this, right? Well, the good thing is that there are a whole set of operations. We learned about arithmetic operations, like we created a new var, and then we created add, and then we can play around with subtract, then multiply. We play around with a couple of these, right? And we probably play around with more of those. There are a whole set of operations called comparison operators. We're also going to see other names like relational operators, but comparisons are a very common one, like equal, unequal, greater than or equal to. These guys are called comparisons, right? Because they compare values. And the result of a comparison is always a Boolean. For example, I have an equal here. I'm asking if, let's say, 10 is equal to 2. So this comparison, is 10 equal to 2? As you can see, it's represented here with the double equals. A single equals means a set or assignment, like we've been using, like if we set like a set node and set like bool var to true, you see that it's a single equals, means I'm setting the value. Double equals means I'm doing a comparison. That's important to note. Okay, to 5. Yeah, I said 2, right? So is 10 equal to 5? If it is, change what's in locker versus comparing what's in two lockers. Exactly. Well, if we say that a locker is a variable, we can also compare numbers that are not in variables. Like 10, we didn't create a variable. But we could also create a variable. For example, I'm going to create another variable here. And I'm going to set that to 10. So now I'm going to compare the value of equal to is var equal to 5. So it's the same thing, just like we did. We are assigning a value, like we saw that before, right? And here we're comparing the value inside the variable var, which is 10, to 5. Is 10 equal to 5? If it is, that's true. If it's not, it's false. That's the basic idea. And to show you guys, I'm going to use a print bool function. We use print int as well, and we can also print bool values. Same thing, but now we pass the variable bool var. So what do we expect to see? Well, I just told you that, guys, that the result will be either true or false. Is var equal to 5? Is it, guys? It's not, right? So it's false. So if I print the result, I expect it to be false. And it is. It prints false because it's false. If I say equal to 10, then it's true. I can do crazy stuff. I can do like var equal to var. Is what's inside the locker equal to what's inside the locker? Yes, it is. Okay, so another cool suggestion. We can combine these expressions, comparison expressions, to what we already learned, arithmetic. So we could do like, is var equal to 5 plus 5? What do you guys think? You guys can see that the parentheses work like this, right? Because of the order that I wrote. True, it is true, because 5 plus 5 is 10. I can also do it like this. So you can already see that you can really start, to create a very cool web of operations. Like, is, let's say, var plus var equals to var times 2? Should be true always, right? No matter the value of var. So true. If I change var to 5, should also be true. So this is the cool thing about comparison. And you can also do things like greater than, right? Is 10 greater than 5? Right? True. And you can also test less than, 10 less than 5, everything like we already saw. So it's a whole new set of operations. Like, it's pretty intuitive. We have equal, unequal, greater than or equal to, less than, and less than or equal to. Those are the new operations that we're talking about here. And those result in Boolean values. And like you can see, we can print those values. What about var equals hello? Okay, so that's an interesting thing. Can we test var equals hello? Let's try compiling that. Okay, try to operate on two values of different types in this node. One is int, the other is string. So the problem is you can't operate on values of different types in this program. Oh, depends on, like, programming languages have different stuff. So this is like the specification, right? But when you're talking about operations, you're usually talking about operating things of the same kind, right? So yeah, you can't compare int to a string. It's like you can't see if a string is greater than another string. It doesn't make sense. But if you change that to string, like Danny is suggesting, it compiles. So is it going to be true or false? It's going to be true. Okay, and if we change that to high, that'll be false. Okay, so you can't compare strings because strings have the same type. You can ask if they are not equal, and we're gonna do like string comparison pretty soon. That's pretty cool. But it's O1 or ON. It's ON now for people who care. But yeah. Okay, but I still love you guys. I forgive you. Now, what cool stuff can we do with it? You already know how to read things from the user, and now you can operate not only arithmetically. Well, with arithmetic, I suppose. And you can also do comparison. Okay, so let's do a pretty cool program. Let's say we are the security guard of a nightclub, right? And we are this big, really strong guys, and we have to ask the age of the person trying to get inside. And if it's less than 18, we're not going to let it inside. Okay, arithmetically. Okay, arithmetically. Yeah, sounds a little bit nice. Arithmetically, yeah. Yeah, arithmetically. Okay, thanks. It's kind of another shame on me kind of moment. So, int. We're gonna read the age, just like we did before. What is your age person. Maybe how old are ye person? I'm trying to intimidate it, right? To make sure that it tells us the truth. Teachers can also learn too. Absolutely, yeah, absolutely. In fact, you guys teach me a lot more than I teach you guys, especially these experienced programmers on stream. But that's awesome. I really like you guys, the whole community and stuff. And hopefully, I can teach people who are learn how to program as well. That's the idea. Teach you in a better way. So I read the age. Okay, if let's just do the condition, right? Let's test greater than or equal to 18. So that's what we want to test. I can enter. The user can enter if the age is greater than or equal to 18, and then we're gonna print can enter. Okay. Did you shout out your Twitch channel name? Okay, yeah, my Twitch channel is Dan Zaydan. The Discord should be Vizzcode. Because I'm trying to build a community there. That'd be pretty cool. People trying to learn programming. And if you go to like Vizzcode.com, I can show you guys. You can get to like the Discord and the YouTube channel with tons of videos about all the stuff that we've been learning so far. That's pretty cool. So thanks for remembering. So much stuff to remember. Okay. Yeah, community. Yay, exactly. Okay, so can we enter? It's gonna be true if the age is greater than or equal to 18. It's gonna be false if the age is less than 18. Okay? Okay, so please make sure the executor is closed because it was opened, so I can't write to it. How old are you, person? How old are you, Dan McGee? Are you over 18? I'm 23, so it's true. If I were like 17, that'd be false. If I were 18, that'd be true. 28. So yeah, you're pretty much very old. Very old. Really old. 28? Come on, man. You must have like a giant white beard or something. I'm just kidding. Just because I have tons of experience. Right? So true. I've been calling Dusty by a teenage girl. So yeah, I'm not gonna get to that. Open up that wound. Okay. So Danny McGee can go into the nightclub. Okay, I took it as a compliment. Yeah, that probably is a compliment, depending on the intention, I suppose. Okay, so perfect. We have the true or false condition. But if you guys remember, I do shower. I do shower as well, like once a month. I'm kidding. Thank God it's just a video and audio thing. Okay. So if you guys remember from what we were talking about, we have the condition now. We already solved this problem. True or false. But how do we branch the code? How do we do something if this is true or false? And you probably heard that before, because I think it's the most well-known thing about programming is the if statement. If you type if, you can see the if statement there. You can also type like branch. See the if statement? So it's pretty cool. It receives a condition, and it has two possible outputs, the true and the false. Okay, so the condition will be can enter. Okay, and I can really take out this print now. We already know that's working. So if can enter is true, what are we going to do? If it's true, we can do something. If it's false, we can do something else. Something else. So you're going to see this name else. Oh, that I wasn't expecting that, but that was perfect. This else case, which means that, well, we're going to do something if it's true, else is going to do something if it's false. It's going to be what you're going to see in most programming languages for the false case. But here in visual programming, it's really easy. You just pull pins like true. I'm going to print, oops, not scan. I'm going to print welcome. And if it's false, I'm going to print get out of here. Okay, I'm going to compile and rearrange the nodes. And, okay, let's run. If I am 23, welcome. If I am 10, get out of here. If I am 28, like Danny, welcome. We could add like I'm going to do a condition on 28 on purpose, just for the fun of it. You see, welcome. Okay, So that's the basic idea of the if statement. It executes if something is true and something is false. Where are your parents? Yeah, it could be where are your parents? Where are your parents out of here? Okay. Okay, and let's say that in the very end, so after we diverge, so let me go back to the crossroad kind of to the image, this road. So just for you guys to see, this is the condition. Can enter. If it's true, it's going to go to the true route. If it's false, it's going to go to the false route, right? And after doing either one, the condition is going to continue the previous pin execution. So I am going to remind you guys something that we already discussed about this pin. So the global scope starts here. So import is the global scope start, then main is the global scope, and then we execute main. The age is going through the main execution, right? But the age has a value, so we execute the value, we do the scanning, then we continue the main execution, then we create the variable can enter, we calculate if it's greater than 18, true or false, then we continue the execution, then we see the if can we enter, true, we print, false, we print the other thing, and then we continue the execution. So this thing here, that we're going to add another print here, like by, this by here is going to execute whether or not these guys run. Couldn't find an image for where the tracks converged. Yeah, but I think it got pretty clear for the folks at home. Well, you are also at home probably. I am also at home. So I think it was clear because this condition here will continue the execution no matter this part, right? So if it's true, it's gonna go. This can be huge. Like if I print a lot of stuff here, I could be a long time just printing stuff or executing other kinds of stuff, creating variables. I could do any kind of code here. And then after I finish this execution, see that it doesn't go anywhere here, kind of ends here. And then I continue this one, the parent execution. So that's how the flow control works. And guess what? It's just the same in the code. That's what I really liked about the way that I created this visual language, is that it perfectly mimics the code. So let's go back to the code, try to compare these guys. So we have the if can enter, right? If it's true, true is the first block. It's called a block. It's between curly brackets here. This block is the true commands, okay? Then we're going to print welcome. And if we add another print here, just for the fun of it, welcome, sir, or ma'am. Or ma'am. Like this? Yeah, madam, right? Ma'am. Okay. Oh, forgot to close. Okay. So, welcome. Ma'am, yeah, exactly. Madam, right? So, welcome, sir, or ma'am. So, in this case, see what we have. This block will execute if it's true. So, it's coming out of the true. It's going to execute print. It's going to continue and execute this other print. You could add another if here. It's going to be arbitrarily complex. And then after that, it's going to go back to this other execution. Just like we see here. We're going to execute this. They're going to skip this false one because it's true, not false, right? Then we're going to go back here. Let me show you guys the program executing. So how old are you? Let's say we're 28. Welcome, sir. Welcome, sir or ma'am. Bye. Well, let me add a new line here in the bye. Just so it's a little bit clearer. So that's precisely what we got. Let me show you guys. Kind of small here, I think. But how old are you? Person? 28. Okay? Then I see if I can enter. If it's true, yes, it's true. So I'm going to print welcome, sir or ma'am. Right? And then I'm going to continue the execution after the if to the by. Okay? If I say like, I don't know, 15, where are your parents? Because it went straight to the false execution, right? Then after this pin ended here, we continue back to the parent pin. Okay, so that's the basic idea. Hopefully you understood, and that's a very important concept to understand both in the code mentally, like this condition thing, as well as the execution here. Okay? But let's say that you must be over 18 and less than 28. Because, I don't know, if we're having a party, we're not going to invite Dandy McGee, are we? Come on, guys. We're not going to invite him. So we can't say that we're not going to invite him, so we're going to add this restriction just to, you know, just to say, okay, Dandy's not going to come in because he's too old. You know, he's dusty. He's just dusty, you know, just dusty. How are we going to do that? Because we have a condition. If it's like, maybe we can change the can enter to like over 18. I can do like over 18 like this. Numbers are okay. I can't do like 18. I can't do like the numbers before. Invalid name start. I can't do that, but I can do over 18 like this. If it's over 18, and it starts shaming me. See, you can't step away, man. I have to be connected. There's too much information here. Density is huge, man. And yeah. So that's the cool thing about this condition. So we have this over 18 condition. We are also going to add a over 28, let's say over 27. Yeah, let's do it. Well, under 28. Under 28 does not include 28, so we're going to do less than. So if age is less than 28. So now I have two conditions. And before doing the print, I'm going to delete this. I'm going to print the first over 18 condition. I'm going to type a little bit, just so you guys can see under 28, just so you guys can see the nodes being generated. That's pretty cool. And in the middle, I'm going to add a new line. Okay, so I'm just going to print the over 18, true or false, under 28, true or false. So we have two conditions now. How old are you? Let's say 23. True, true. So I am over 18 and I am under 28. Let's say if I'm 10, I'm not under 18, over 18. I'm been saying under 18. So it's over 18 and under 28. I'm 10. Am I over 18? No. Am I under 28? Yes. If I am 28, I am over 18 but not under 28. So we have these two conditions. And if we think about like everyday activities, like I don't know, if it's raining and I'm late, I'm gonna go by car. So well, that's kind of was a bad example. But the idea is we use and all the time. And this and thing of combining two different conditions, like, well, if you continue, slight tangent, can you try? Yeah, we're gonna try that in a second, Danny. I think it's gonna work because it's just a normal Windows console, to be honest. It's just an exe, yeah. So if you talk about conditions, we think about and all the time as a way to combine two conditions. For example, well, is the information being passed in the tutorial and it's under 3 hours, let's say. So if it's under 3 hours, yes, it is. And is information being passed? Yes. So both of them are true. One and another is also true. The interesting things happens when you try combining these true and false on what's usually referred to like the truth table, things like that. These kind of funny names. But the idea is, let's say I have true as one value of the and, true or false. It's one of the possibilities, right? And then I have true or false to the other as the other value. Okay. If I say this guy, one of these and one of these, true and true. So if one thing is true and another thing is true, the result is true. So right now, just to be clear, we're talking about Boolean or logical operators. Okay, so true and true becomes true. True and false is false. So if the end works like it's only true if both of them are true. So it's going to be false if false and true. It's going to be false if false and false. And it's going to be false if false and true. False. Well, this may have been a little bit confusing, but it's going to be easier to understand here. So we have two conditions, over 18 and under 18. What we want to do is execute some code if both conditions are true. So one and the other. One if it's over 18 and under 28. So let's type and there you have it. We have the and condition. And as you can see, it creates like this double and %. That's how you're going to see this Boolean and a lot in programming languages. So I'm going to just add the, over these two. So what I'm creating this condition is if over 18 is true and under 28 is true, then execute this. Okay? And as you can probably see, we could add another variable. We could just create a condition variable and add a condition here. Same thing. Like we're just assigning this value of this expression to a variable, and then setting the condition of the if condition to the variable condition. Okay, but we could just set that directly, like and we're going to turn off the contextual filter, right? And I can even go one step further than that, and to do these tests directly on that expression. So I have like a huge expression, like, well, not huge, but pretty big. So if the age is greater than or less than, is greater to or equal to 18, and the age is less than 28, the age is less than 28. So see, I can add that to variables like we did previously, separate variables, or I can just do the same thing in one expression. Okay. So yeah, there you have it. So this condition will be, as you can see in the code, is just the and here. And just like before, we could type this whole expression. I'm just going to remove this whole thing here. True. I could type the whole thing here as well. So age is greater than 16 and age is less than. See, I could add the same thing here. Or I could add the nodes, same thing. But I think it's easier just to have the nodes like this. And the expression here. So it's pretty cool. So now we combined these two expressions to have a specific condition. So I'm going to print welcome. And then I'm going to print not welcome. Well, that's not very exciting. Not welcome at all. Okay. A little bit more exciting. Forgot the quotes. Okay. Let me organize the nodes here. So that's the basic structure of this program. Let's see. What's going to happen if the person is 20? Welcome. Because the age is greater than 18, or equal to, right? And it's less than 28. Am I, if I am 30, I am not welcome at all because I failed this condition. And this is true, but this is false. It's going to be true and false. True and false is going to be false. It's going to be true. Can you send age to two places without having two age nodes? No, a single node can only connect to a single place. But you could type age here. I don't know if that helps, but yeah. Yeah. So yeah, this section we learned a lot of stuff, to be honest. We learned about Boolean values. We learned about comparison, like we're doing here. We learned about logical operators. Well, let's add more logical operators to the list, right? Because there are only two more. And one of them is pretty easy. Let's do the easy one first. Boolean is either true or false, right? One thing we can do is invert the value. So if it's true, we're going to make it false. And if it's false, we're going to make it true. And that's called not. Not is kind of a, if I type not, it's going to be like, it's represented by this exclamation mark, as you can see here. The idea is, if it's true, it's going to be false. If it's false, it's going to be true. So it's going to literally be the other way around. For example, in this case, it's going to do, let's say if I say 20, okay? 20 is greater than or equal to 18? Yes. So this is true. Is less than 28? True. So this is true and true is true. Not true is false. So false, I'm going to run this branch. Okay, was that clear? It's opposite day, yes. So 20, not welcome at all. Now if I'm 10, I'm going to fail the first condition. It's going to be false and true. False and true is false, but not false is true. So I am welcome. Okay, so again, 10. 10 is greater than 18? No. Less than it? Yes. So false and true is false. Not false is true. So it's going to be the opposite, right? And we have our condition. This can get confusing, but the idea is that these expressions are merely tools at your disposal. So that's why, and Dan is completely right when he says that if you don't practice it, you're not going to learn it. And you learn it when you can easily apply that. Okay, so I'm going to teach you the last one, which is very similar to AND in terms of like idea, right? That is the OR operator. And you can already imagine what happens with the OR, right? For example, well, let's do the DH thing. If he's less than 20 or he's 18, gives a different color in the other type separate. Yeah, I guess that's better. So let me just pick a different color here. Well, that was kind of bad. So or, and this is like true. Wow, that was really bad. And false. And true and false. Or kind of has this meaning of either one. If either one of them is true, either or, right? If either one of them is true, it's true. So if true, it's going to be true. True or false is still true because one of them is true. Bit better. Yeah, I suppose it's a bit better. Yeah, it's kind of ugly. This is not optimal, but it is a bit better. True. But false or false is just false. So the small thing to understand here is that AND will be true only if both of them are true, and OR will be true if any of them is true. Okay, so that's the basic idea. And you can play around with that for some interesting things. For example, if we are greater to, let me take out this not guy. If we are greater to 18, greater than or equal to 18, or, and the OR is represented by these two pipe symbols. So that's kind of weird. But if you type OR, you're going to see that. And in the text code, it's usually going to see these two pipes. If you are over 18, or let's say age equals 5. So if you are 5, or if you are over 18, so if either of those is true, if one of them is true, then you are welcome. So if you are 28, you are welcome. If you are 23, you are welcome. If you are 18, you are welcome. If you are 17, you are not welcome at all. But if you are 5, you are welcome. Okay, if you are 4, you're not welcome. So I hope you guys can understand how we can combine these to interesting behaviors. Okay, so these are all the tools that I want to teach you guys in this section. Now, let's go to a couple of exercises, but now I'm going to solve with you guys. Okay, so a couple of easy ones first. Let's go to the condition executing. There's this like conditional execution, which is super simple. Create a program that reads two numbers and types the first one is greater than the second, only if the first number is greater than the second. Or the first was not greater than the second if that wasn't the case. So uptime, well, the uptime is 2 hours and 49. I don't have a bot, so 2:49. Yeah. that looks easy enough, right, guys? I think you guys are able to. Yeah, well, I was hoping to go to like 3 hours, but I think we're gonna get to 4 easily. Yeah, but I want to finish this whole thing because there's a lot of good stuff, and I think it's a very, very light-hearted kind of a tutorial, different from the other ones we see. We also talked a lot about programming the lower level in the beginning. That was pretty cool, and there's also a lot of exercises in it as well. Okay, so can you guys do this one by yourselves? I'm gonna ask you to pause the video and try, and if you want hints, you can check out Vizzcode.com and go to the hints, and maybe I can review that to you. I don't know. And then we'll build that together. Okay? Okay, so hopefully you were able to solve that. It's not very hard. Let's do. So we're going to read two numbers, first number and second number. If the first number is greater than the second, we're going to print this, else we're going to print this. Doesn't seem too hard, right? We've been doing this stuff pretty closely to what we want. So first, so what do we have to say? Enter the first number. I'm going to just copy that. Enter the first number. Then I'm going to copy the whole thing. Type second number. Easy, right? Then I'm going to test if the first number is greater. I'm going to print that or this. Okay? So if it's greater, so if first greater than second, see the expression that it generated? I could also work like this. If it's greater than the first, it's greater than the second, could also do that, same thing. What are we going to do? We're going to print first number is greater than second. If it's not, just going to add the print here in the false. If it's not, I should add just, oops, got the whole print here. Just copy the message. See, that's kind of a sign of a little bit of a lazy instructor. You copy the text and make your notes magically. Yeah, that's the magic thing, man. You can type here and here interchangeably. So when the programs are getting big, like the video games, they get pretty big. I'm going to show you guys in the very end. I'm going to show you guys a video game I created with using Vizzcode. They get pretty big. But the cool thing about them is that you can organize them with text and with nodes. And there are some things that nodes work way better, especially like calling big procedures, like spawn particles with tens of parameters and stuff. Nodes are really easy. You can really see the parameter name and default value and stuff. But text really has some advantages. And you can create nodes with the text pretty easily. So let's try running. So try to follow it here as the execution happens. Let me try getting these nodes together just so you guys can see. Okay, so again, I'm declaring that there is a library imported called IO and a main procedure, and then we're going to execute. So what is the program going to do? It's going to create a variable called first and assign that the result of what I'm going to type. So enter the first number. I'm going to type 50. Now 50 is saved inside the variable first. Okay. Now the second is going to hold enter the second number 12. First is greater than second. That's what we wanted, guys. That's what we wanted. So let's do 12 and 50. It's not greater than. We did the exercise. Not too hard, was it? Hopefully you guys could solve that as well. Or maybe with me creating that, maybe you guys can see how it was solved. Let's create another one. Let's see. Let's play this one. This one's cool. Let's play. Create a program that asks the user if they want to play. If the answer is yes or sure, the user has to guess a number, a random number between 1 and 10. If the user gets it right, the program congratulates the user. If not, the program simply says not to try. If the user doesn't want to play, the program says all right. Either way, the program says bye. So we're going to use everything we learned so far in this program. So these are a couple of examples of the execution. They want to play no, all right, bye. We're going to play sure, guess a number from 1 to 10, 5. Yeah, you got it right. They want to play yes, guess a random number from 1 to 10, 5. This time it wasn't 5. So nice try, but not this time. And then I say bye. Okay, so couple tips before you try to solve this by yourself. Do one step at a time. Don't try to create the whole thing. Do one thing, then compile, and then run, and then test. Then add another functionality. You don't have to understand the whole thing. You know, the more complicated software you create, the less you understand the whole of it. And as long as you do a steady improvement of the parts individually, you're gonna have you only get one chance. Yeah, that's bad. It's bad game design. It is. Well, the next one is even worse. I'm not gonna read you guys. This one's pretty bad. Which one? This one's great. I'm gonna show you guys this one later on. This one's pretty cool. But yeah, that's the first bit of game you guys can do. You guys can start making pretty interesting games with what you learned so far. Like this one. I'm gonna show you guys. It's a lot better than the lottery, man. 10%. If I have 10% chance to win the lottery, I play the lottery every day. Okay. So yeah, the big tip is that do each step individually. So create one thing, test, run. It may be overwhelming, this whole thing, but try to break that problem into smaller problems, and break that smaller problems into smaller problems even still. For example, create a problem that asks the user if they want to play. If the answer is, oh, first of all, just ask the user if they want to play. Just do a print. And then you can test the answer. You can record the answer and test if it's just yes, or then yes and sure. And then just print that as well. What about random numbers? Well, I don't know about random numbers, so maybe I can search that. Maybe I can look for the hands here. And then, you know, each step you can expand the program one step at a time. Not try to do the whole thing at once. Then it's going to be overwhelming. That it always is. No matter your skill level, the programs that you try to tackle are overwhelming if you don't break down the problems into smaller problems. So that's the biggest tip of problem solving we have at this moment. Okay, so pause the video, and I'll give you, well, how much time you need, to be honest, to solve the problem. Okay. Okay. Hopefully you were able to solve it. I hope you did. If you did, I will be very proud of you. If you didn't, there's no problem. You're going to have a lot of chances. Generate a new random number is different and tell them they lost. Okay, yeah, I could tell like if they lost like both times. There's a pretty funny quote on that, but I'm not going to get to that here. Okay, so first of all, do you want to play? That's one we want. I'm going to delete the whole thing and start from absolutely nothing. So this is as if we've just created an empty project. So if we are going to print and scan, right? So we need input and output. So I'm going to import the library. I'm going to turn that contextual feature. I'm going to import the library IO and do the main procedure. So this is the basic setup for this program. I'm going to have now the main, the print, and the scan functions at my disposal. And then I have a place where the programs are executing. Okay, let's just print what they asked us to print. So do you want to play? So this is the beginning of the program. We want to play? So we already have this part. But now we have to read the message that the user typed. We already know how to do that, right? So we're going to create a variable to store the answer. We're going to call that answer. And then I was just double checking if that's correct. And then we can do the scan. Instead of printing the message, we can pass that message to the scan and it will be printed. So same thing. So now we ask the user if they want to play. So we are improving, right? That's that. Do you want to play? Well, I suppose there's a space missing. If they type yes, it's going to be like, I'm going to add a space after this guy. Okay, so do you want to play? Yes. Oh, I didn't type yes, but it didn't do anything. So whatever I type, it's just going to finish the program. Okay? Is there a context menu or a hotkey? Yeah, the context menu. Oh, you mean like, yeah, this is the context menu. It opens based on the node that you're selecting. For example, right here, it's an execution pin. I can create these nodes. If I create these guys, this is an expression. I can create these nodes. So yeah, but you can also see the whole thing. How do you remove nodes? That's a good question. I kind of showed it, but I didn't tell you guys. Just press delete on the keyboard. Just press delete. Easy as that. So do you want to play? We have the answer saved in this variable. Now, if he's kind of telling you the answer right here, right? If the answer is yes or sure, the user has to guess the random. So it's pretty easy, guys. If the answer is what? If the answer is yes or sure, so we can start like if the answer, right? If the answer is yes, so if it's equal to yes, or we can also do like this, right? It's pretty easy. Or if it's equal to, if the answer is equal to sure. See, this is what the if statement look like. If the answer is yes, or if the answer is sure. Okay? And then what are we gonna do? User has to guess the number between. We can do the false first. The false is just going to say all right. If not, the program says nice try or all right. Oh, I'm sorry, I was reading it wrong. If the user doesn't want to play, so this is where we are at. See, have to really be careful. Then it says all right. So we're gonna say all right, and then we're gonna say by either way. So we already learned how to do that, right? So in the false, we're gonna say all right. We're gonna skip a line, so add a line break here. And after the if, no matter the result, we're gonna say bye. Bye. Is there a way to do a case insensitive string comparison? There is not. I am kind of owning you guys to do a more comprehensive string library with all sorts of crazy stuff, like appending strings and stuff, but there isn't yet. Actually, there's probably going to be an error when you try to do like crazy string operations. It's going to say, oh, you can use the string library, but it's not ready yet. Yeah, because it depends on kind of a lower level stuff on the language. But yeah, right now you could, like if you want to do like the case insensitive search, like Danny suggested. Can you guys do that? So the point, let me just explain the problem so you guys can solve it. He can type yes like this, but if he types yes like this is going to be false because this yes is not the same as this yes. So yeah, to lower that kind of stuff, would be in the library. So how can you do to test both cases? Do you guys think about that? That's an extra point in the exercise. Okay, the way to do that is to create another OR. So the OR is going to be 4 ORs, to be honest. It's going to be if the answer is sure, or yes, or if the answer, oh my god, if the answer is yes, oops, equals, the answer is yes with capital S, or if the answer is sure with capital S, capital Y, I mean. Okay, so that's the basic condition that we added. See that it's starting to get pretty big. If it's yes, or if it's sure, or if it's yes with the capital S, or if it's sure with the capital S, capital Y. Then we're not going to do anything. We can just say play the game. Play game. And add the new line. Just to test. Do you want to play? Yes. Play game. Bye. Want to play? No. Alright, bye. If I type junk, alright, bye. If I type yes with capital letter, play game. If I type sure, play game. If I type sure with capital S, play game. If I try yes, please, alright, bye. So this was no, because it's not yes or sure, or yes with capital Y, or sure with capital S. Kind of confusing. Yeah, feels like there's too many ways to do the same thing in the node. At least 3 is generate the same code. Yeah. You know, you have a good point there. You know, I think I'm gonna standardize this condition like this just to make sure that it kind of looks the same. And you guys can explore the other ways as you get comfortable with it, I suppose. Okay, oops, you got on top of the other guy. It's too close together, like this. Okay. So yeah, I think it's going to be way easier. In fact, it is. So if the answer is equal to yes, or sure, or yes, or sure. This is way better, to be honest. So thanks. And this is the text. It didn't change, just like it said. Okay, then we're going to play the game. It says, all right, false. But now let's do the game part. The game is the program. Okay, so the user has to guess a number between 1 to 10. If the user gets it right, the program congratulates the user. If not, nice try. So we're gonna have to guess a number for from 1 to 10, for 1 to 10, from 1 to 10, I suppose. Okay, so we're gonna read the number, so it's gonna be a new variable. I can use a control click to disconnect, but still keep the node. Alt click will make the node, will make the connection disappear. So if I add like a new variable here and call it guess, then I can add a scan int because I'm gonna read a number and type a random number from 1 to 10. Okay, then what I have to do, I have to test another condition. I have to first of all create the correct answer, which is going to be a new variable, correct. Okay, but how do I create random numbers? Well, it's really easy, to be honest. It's kind of it's not even fun because it's really easy. Just going to add a new library called random. And now you have access to random int in range. That's it. That's the only thing I have to do. But that's good, right? Because you're going to get to the creating your own programs, not like figuring out how to do stuff like that. That's so random. Yeah, that's pretty random. That's kind of random. It's not random at all. I mean, it's random because you want random numbers, but it's random for a reason, for a purpose. So it's kind of doesn't make sense. Okay, so this procedure is pretty much the same as the scanint. It receives a few parameters that we can tweak, and it outputs, so it returns a value like this that we can use to use random numbers with. So it's from 1 to 10, right? So minimum inclusive, so 1 and 1 can appear, and 10. Okay, easy enough. Now I have the guess and we have the correct answer. Now the thing is, if the guess is equal to the correct answer, same thing you guys have been doing for fast break exercises. If the guess is equal to the correct answer, oops, not the guess again, the correct answer, then we're going to congratulate the user. Yay, you got it right. It's going to be hard to test that because, oh yeah, 10%. Let's see how lucky we are. Else, we're going to print, nice try, but not this time. Okay? There's also a nice extra new line here. So before the guess the number, I'm going to add a new line. And the alright will also have a new line, as will these guys. This is just like making it easier for the inclusive versus exclusive. Excellent. Yeah, so inclusive, it's all inclusive. Means that the 1 can appear as a random number. And the 10 as well. So the numbers from 1 to 10 will be 1 or 2 or 3 or 4 or 5 or 10. One of these numbers. This is how it's set up. So do you want to play? Yes, let's play. Guess a number. Dandy, guess a number. Let's see how lucky you are. Let's see if you're going to win the lottery. 4. Nice try, but not this time. I don't know, do you guys want to test until you get the random number? We can do like pro stuff, like if we, for example, print both numbers, oh, not both numbers, if we print just like the correct number, we'll be able to test if it's working or not, right? Oops, 5 means no. So if I do dev hacks, exactly. So you really want to test your program, but the more complicated the input is, like our game's pretty complicated and stuff, you want to make it easier for you to test, right? So this is one way you could test this system. 7, because it was 5. Let's do, oops, let's do yes and try 10. It was 2. It was 2 again. Well, let's try 2. It was 8. Okay, so I am going to do another hack. And I'm going to set the guess to be the correct value. Okay? So yeah, we could also print the correct value before guessing. That would be a good way to test. But this is another pretty interesting thing. We can set the guess to be the correct value. So this should be correct always, no matter the number we test. So if we say yes, 5, I couldn't even say 55, to be honest. Yeah, we got it right. Okay, because it's the same. But let's do Dandy's test. So first of all, we have to change the order of these guys, right? I'm going to do this in text. It's going to be easier. So first of all, have the correct node. Oh, and just to tell you guys, these are like pro shortcuts. I can do like the arrow keys to move, right? These guys you should be familiar with, right? I can also hold Shift to use the arrow keys to select more stuff, right? If I do this, it's the same as clicking and dragging with the mouse. Okay, this is by holding Shift. I can hold Control to go word by word. So correct, random, int, in, range, 1, 10. So I can go this by holding Control. If I hold Control and Shift, I can do both of them at the same time. So I'm moving them word by word and adding them to the, I don't know, the buffer or whatever, the marker here. Home goes to the beginning of the line, and goes to the end of the line. I can hold Shift and press end, then it selects the whole thing. I press Control X, means cut. Same thing as doing Control C and then deleting. And then Control V pastes the line again. Don't need to worry too much about that. You're going to get the hang of it in time. But these are programs that are small enough that you should be able to get the hang of it simply by playing around. Okay, so first of all, we make the correct number. Then we're going to print int. We're going to print the correct number. And we're going to play yes. Okay, so 1. So that's a dev hack. A perfect one. Yeah, we got it right. If we type another number, it's 8. So let's say 5. Nice try, but not this time. So pretty cool. Pretty cool. Awesome suggestion. Perfect. So we finished the exercise. See, when you look at this way, it's pretty big, right? It's starting to get complicated programs and has lots of like small cases and functionality and ifs inside ifs and ors and stuff. But as you saw, we did a very step-by-step approach. So yeah, it really makes it easier to do programs like that. Okay? So I really suggest, oh wait, I'm going to show you guys the other exercise. I really suggest that you finish all these exercises, all the print ones. And this one is really cool. So this one, how does the graph have any collapse? Oh, you can't collapse yet. So the idea is that in the near future, you'll be able to just collapse this, or maybe by just zooming out. This will be less detailed. And you'll be able to like see the name main. It'll be cool because this way you can like easily move around the program in a higher level if you have like tons of procedures and stuff. That's going to be really cool. But that's going to take a while because it'd be hard to transform to different manifestations and stuff. So okay. let's simply oh, I'm going to show you guys this exercise. This one's pretty cool. I'm going on an adventure. This pretty much gives you a prompt about text adventures. Tells you guys some examples of them and how user interacts. And then there is a text adventure that I created here. This is like the whole thing of the possibilities and like the connections. Well, if the user says this, he gathers a sword, and if he has a sword and tries to fight a goblin, but if the goblin, so there are lots of cool stuff in this. It was a pretty cool story that I created, I think. There's also the text transcription that you can check out and copy, so you don't have to type the whole thing. And perfect. With that in mind, so this is the thing. So you quickly grab the goblin's neck. So a random chance. Then you set to being chased. So like here, if you're being chased, then this happens. And so that's a pretty cool thing. So with everything you learned so far, variables and if conditions and stuff, you'll be able to create a pretty cool story, interactive story. This one I designed, but then I challenge you to design your own, which is even cooler than that. So yeah, I should really recommend it to stop and try to get a hang of it, because that's pretty cool. But now I am going to jump ahead to loops, which are the next subject that you're going to learn when you're learning programming, and there are some pretty cool things there. Okay, so loops, pretty easy. Just like we talked about the execution flow with ifs that branch the code, loops simply go back to places of the code, like executing these instructions, but at this point, maybe on some condition, maybe indefinitely, you know, something happens that we go back to the instruction and keep repeating them. Okay? The idea is very simple. So, for example, let me just delete this whole thing. Let's say we have a print, hello, right? Like you guys saw the very first time. Hello. Let's say I want to repeat this hello forever. Okay, let's do that. How can we do that? Well, the while loop is a pretty awesome way to repeat parts of the code. So the while loop is pretty much like the if. So it receives the condition, and then it loops a certain body of code based on this condition. Or to be more precise, it loops it while the condition is true. For example, I'm going to start the program, then while this condition is true, so just like the if, I could type condition here, I could create a variable, I could make a complex expression here, just like, you know, while this is true, repeat these instructions. So let's add another one. Let's add like a bye one. Hello and bye. I want to say hello, bye, hello, bye, hello, bye, forever. So while, if I want to repeat this forever, I can just type true here, because the true is a Boolean value, right? True or false. That's going to be always true. So it's going to be pretty much going to work for us perfectly this time. So it's going to be like, it's true, true, yes. So print hello, print bye. Then it's going to go back and test again the condition. Is true, true, yes. Then it's going to loop again, test again, loop, test, loop, test, loop, test. It's going to do this until this condition is false, and it's not going to be false. So what will happen when I press run? That's going to be pretty cool. You guys want to see? So it's quickly saying hello and bye, and it's gonna keep saying that forever until I close the program, because this while loop is an infinite loop. That's pretty cool, right? You did matrix effect. Yeah, it's pretty much a while loop, but you can also have to change those. Printing 0 and 1 forever. Oh, I see what you did there. I see what you mean. 0 and 1. Maybe it's going to be too fast for us to even see what's going on. Yeah, well, that's pretty cool. Huh. I'm going to do, you gave me an idea. I'm going to do some crazy stuff with this. But let's just print like, got to be random lines of 80. Exactly, that's what I'm going to do. So we had the same idea. Yeah, I could not do the random line, but I think that's going to be kind of ugly, man. Let's see. Yeah, this is starting to get somewhere, but I liked Dandy's idea better. Let's just try to not print the new line. And do like 0 and 1. So see, when we have a new subject, a new feature like this, it's awesome, guys, for you to just try around and experiment. What do you guys want to do? Like, what ideas did you guys have? And kind of a chase them. Let's see how. Oh, it looks bad, to be honest. Well, let's combine that with what you learned about ifs and random numbers, right? So it's kind of what Dandy said. So we want to print either 0 or 1, because if we print 0 and 1, it's kind of the same thing, right? It's kind of boring, right? So this is what we're going to do. We're going to do an if statement. If some condition, and we're going to try a random condition, right? We're going to print 0 or 1, okay? What condition is that? First of all, we need a random. We already have the random, right? Let's say if a random number in range, let's do like, oops, got the wrong thing. If you get like 0 and 1, so this random number is going to be either 0 or 1. So it's going to be a 50% chance. I'm going to turn the context filter off. So if the result is 0, so 50% chance of one of these guys. Okay? Or just alternate it. Don't do the and. Don't do the, yeah, no new line here, man. But it is going to break a new line. Can just print the random result directly. Yeah, dude. I wasn't thinking about that, but that was a pretty good point. Like we said, like we saw earlier, there are usually multiple ways to do the same thing in programming. So this is what I wanted to do. I'm just going to show the result. This is pretty cool, I think. Now you can show this to your friends, and they're gonna think you're the best programmer ever. Is it not? Look at that. This is like next level programming. But Dandy thought about a way to do this that's gonna be way easier. Instead of doing this guy of testing the if greater than equal to 0 and then doing the if, we could simply print this result. So it's kind of an obvious thing, but it's great. That's why I don't have to think too much about how to solve a problem, because usually you're gonna get somewhere interesting, and there are so many paths you can take. And the more things you learn about programming, the more ways you can do the same thing, right? Full screen. Awesome, let's go full screen. Dude, I don't know if you guys saw that, because, dude, my full screen is 4K, and I'm only showing you, well, now it's the matrix effect, right? I'm only showing you guys, oh, I'm gonna have to show you guys full screen. Oh, this is gonna be really bad, but you guys can see, let's see. I'm gonna add another display capture. Hopefully OBS won't explode. Okay, but then I have to scale it down. Oh my god. Just so you guys can see what I'm seeing. Okay, this is what I'm seeing. This is awesome, right? So, dude, I don't know. I think I just want to look at that a long time. And you can almost see like a map being formed, like a video game map. Let me try something else. I use Control-C to break out of that, just so you guys know. I can see Neo. Yeah. If we do, I'm gonna go back to my equal thing. If I'm gonna print either 1. Oops, I'm gonna do like if it's true, I'm gonna print 1. If it's false, I'm gonna print a space, an empty space. Okay, so maybe it's gonna be clearer first. Oh, you guys probably can't see oh, you guys can see my notes. Okay, this is starting to get interesting. Like, it's almost, we can see like a path forming, right? It's beautiful. It's beautiful, really. Oh, random stuff. I'm gonna have to do a little bit more. I'm gonna do like a 50%. 50 is too much. Like 1 in 10. 1 in 10 is going to display the 1. Mr. Anderson. Okay, so now it looks like Star Wars. Look at that, man. We could even, instead of 1, we could print like dot, just to. Oh yeah, dude, we have a space game already. Dude, it's almost like I wanna just say, okay, it's done. That was like the apex of programming. But this serves to show you guys that just play around and experiment. It's really awesome. You can really get some interesting cool stuff, and you can keep adding to this idea and really chase it to like some pretty cool things, to be honest. Let me just go back to the normal setup. Okay, so guys, super fun. Yeah, programming from more patterns from down 70 to down 80p. I see. Yeah, that's interesting. It's gonna be, yeah, you guys can create all sorts of good stuff with this. So that was pretty cool. Yeah, that was really fun. So this is about creating. So I love it. I absolutely love it that we got that moment on video. And that's the advantage of not doing like a very structured tutorial. It's kind of structured, but not totally controlled. In the sense that this is the good thing about programming. It's like we want to create something, but we find out what it is by just creating, and then we play around and chase ideas and then have other ideas. That's great, man. That's just awesome. But as you guys can see, this condition, you can do some, I don't know, some like more control things with that. For example, let's create a new variable. Well, let me do it like this. I'm going to create a new variable outside the while. I'm going to talk about that in a second. And it's going to be a string variable. And then I'm going to do a scan. So type yes. Just that. And then while the variable is equal to yes, okay, I'm going to print Yay! Okay, so right now, what's going to happen is, let's see what's going on. Undeclared, yes, okay, I forgot. So there was an error, and I click compile, and it says undeclared identifier. Yes. So as you can guys know about what we've been doing, is that if you type like var, that's a variable name, right? Var, same thing as just dragging out var, because the program is going to look for identifiers like variables with this name. I typed yes without the quotes. So it was looking for a variable or any identifier with the name yes, and it didn't find it. So that's what undeclared identifier means. But what we meant was just adding the double quotes. That's what we meant. Okay, so type yes, yes. But what will happen when I press enter? Look at the code and try to really understand it. While var is yes, I'm going to print. Then I'm going to test, is var still yes? Yes. It's still yes? Yes. So it's pretty much an infinite loop. Why? Because we can't change the condition from inside the loop. So at this point, I'm going to copy this line. Instead of just declaring with this colon here, a new variable called var, because I can't do that. Remember, there'll be multiple symbols declared here and here. I'm just going to remove this colon. Then there's going to be an assignment, a set. So I'm going to set the value of var that already exists to calling scan again. So type yes, yes. Type I want to print EA first. Just like we've done before, I just reordered the notes. So type yes, yes. So I said yes, yay, and then type yes. Oh, and then I typed yes dot, and then he ended the program. Why? Because it wasn't yes, so the condition was false. Then he exited the loop. Let's just add another print here, and okay, close the exe. Okay, so yes, yay, 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 yes with several s's, and so I do the loop, the entire loop, and after I do the entire loop, I test if the condition is true. In this case, it was false because the var was not equal to yes anymore. Then I just continue the execution down here. That's the basic idea of the while loop. And again, it's such a small thing, like, yeah, okay, I get it. It receives a condition and then loops a certain body of code while that condition is true. But you can create all sorts of cool stuff with it. For example, let's start elaborating a little bit more. I'm going to make a variable. I'm going to call that count. It's going to count, let's say, from 0 to a big number. And while count is less than, let's say, 1,000. Okay, while count is less than 1,000, we're going to print EA. Then we're going to print end. What do you guys? Okay, so yeah, there's still the first problem that we talked about, right? That count's going to be 0. Is 0 less than 1,000? Yes. We're going to print EA. Is 0 still less than? Yes. Yes. It's going to be just like this. But I kind of forgot a small thing, which is I want to increment the value of count so that it's 0. Then it's going to be 1. Then when test is 1 less than 1,000? Yes. It's going to be 2. Is 2 less than 1,000? Yes. It's going to be 3. Is 3 less? Yes. So it's going to be repeat how many times? 1,000 times. So you guys already know how to do this, right? Set. I'm going to set the value of count to be the value of count plus 1. We already did that before. Just to remind you guys. So count's going to hold. So I'm going to place that in that locker. What value? Well, I'm going to get the value of count. Let's say it's 0. 0 plus 1 is 1. So now it's going to hold 1. Next time around, it's going to hold 1. So it's going to be 1 plus 1, 2. Now it holds 2. Now it's 2 plus 1. So it's going to be incrementing by 1 every time. If I run, oh, yeah, it's going to run EA a lot of times, 1,000 times. But yeah, that was not very interesting. So I think I'm gonna print the value of count and then just break the line. I think that'll be better than the A. See? I see 0 all the way to 999. Why? Because it's going to be 999 plus 1 would be 1,000. Is 1,000 less than 1,000? No. So it's going to be false, it's going to break. If you do less than or equal to, then it's going to do up until and including the 1,000th time. Okay? That's pretty cool. Again, now you can repeat a certain part of the code a specific number of times, like do this 10 times or 1,000 times or whatever with this system. But this is such a common thing to do in programming that there's usually a way to do that in an easier way, another loop. Because the while loop, you can do that. You can do pretty much whatever you want with the while loop. There's another cool thing you can do, which is the for loop. If I go back here to the contextual filter, here we have while loop and we have for loop. For loop is pretty much the same thing, but instead of giving you a Boolean condition, like do this while this is true, the for loop is going to repeat the loop part a specific number of times. For example, from 0 to 9, it's going to be 10 times, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be 10 times. Or you can do like from 1 to 10, that's also 10 times. And then, yeah, in this case, we were repeating from 0 all the way to 999. So we could repeat that here, from 0 to 999. And inside of it, we could also print, well, we can print the iterator. See this it thing down here? And it's kind of green. That's because declaring variables is green. Right here, it's declaring an iterator variable called it, right? And you can use this variable. This variable, iterator, is the same thing as the count. It's going to start out as 0, or the number here, in this case 0 as well. And then every time through the loop, it's going to be incremented by 1 in the end. Okay? So then it's going to be tested against this guy. So this loop, and well, let's just print the value. So we're going to print it, and then we're going to print the new line. Yeah, let's do the print new line. So this loop is the same thing as this whole loop, where we create a variable, create this condition, print the variable, yeah, so, and increment it. This is the same thing. So the for is simply a way to, okay, yeah, it's opened again. I have to remember to close the guy. So the for is simply a way to write a shorter while loop that simply does a specific number of times. Because as we saw, the while do stuff like while a certain condition is equal to a certain variable is equal to another, like we saw with strings. So while is more powerful, but for is easier to use. So you can use which one fits perfectly to what you want to do. So let's try running. So let's see what happens. We got 0. Oh, it's going to be kind of hard. 0 to 999, and then there was end. Oh, forgot a new line here. So there was the end, and then there was the 0 in the same line. The 0 is now here in the for loop. And then we add a new line all the way to 999. So 2 ways to do the same thing. Like Dandy said, there are several ways in programming, several things in programming that you can do in different ways. That's good because you're gonna learn in time kind of a, well, maybe this one's a little bit easier, maybe this one's a little bit quicker, things like that. But it's also good because you don't have to worry too much about knowing all the ways, because you'll be able to create whatever you want in different ways. So it's kind of a practice kind of thing. What I want to show you guys is another kind of a set node. So we use the set. There's also the add and set, subtract and set, multiply and set, divide set, modulo and set. Well, we haven't talked about modulo. You can take a look at the exercises for that. That's pretty cool. The add and set. So let's do the count. Let's do 1. Oops, like this. This set, where I'm setting the variable to be itself plus 1, is the same thing of this guy. Look, see how it looks in the text code. You're gonna see this a lot in programming. Plus equals. Plus equals means I'm going to set the value to be the value of the current value now, plus 1. Okay, it's the same thing. Same thing. So if I delete this guy, just leave. Oh, again, I should be closing this guy. It's gonna be the same thing. Or maybe 1,000 was too much. Oh my god, but let's see. Yeah, so you got all the way to the end, 999, then started the other loop. Okay, same thing. Just showing you guys new possibilities. Now, with these loops kind of stuff, we can already create all sorts of cool stuff. For example, let's go back to the exercises. Let's say, let's do the first one. Please type a number. make a program that asks the user to type a number until they type a valid number. When they do, thank the user. That's pretty interesting because it was something that came up with in the beginning of the course. Because when we talk about getting numbers, like we said, from the user, let me just go back to a simple setup here, number, and then I'm going to scan int, message, type a number. The user can type an invalid number, like he can type hello. He can, I mean, that's the way the interaction works. And then it's not a valid number. So like we saw, it's gonna be 0. But that's where the success thing comes in. Because imagine you're making a software where you really need a valid number. Like you wanted the user to type a number, and if it doesn't, maybe you're gonna fail something horribly. So the while loop can be used in this case to make sure that you're gonna, while the number is not valid, you're gonna ask for a number. And that's where the success comes in. This guy is another return value. So there are 2 return values from the scan int procedure. The first one we've been using is the value itself. But the while, see that it's red, means that's a Boolean. It's a Boolean value that's either true if it was a valid number, success, right? Or false if it wasn't. So how do we access this guy? See this little plus right here? If I press it, I'm going to declare 2 variables in one node. That's called a compound declaration. And most programming languages do have some sort of things like that, but using multiple return values with compound declarations are a great way to be able to pass a lot of data around. So I'm going to call this number. But what about the type? As you can see, this guy is an int, and this guy is a bool. If I try to compile, there was a problem, right? Expression was a different type. I wanted int, found bool, because I wanted an int here. See, that's kind of a green here, but I gave a red bool. A red bool. Nice one. I can set it to auto. That will make each individual variable, like num and is number, based on the type of the return value. So I have 2 variables now. 2 variables now. One's called num and it's an integer. One is called is number and it's a bool. So what I can do is something like while. Yeah, while. Kind of lost my train of thought. While is number, right? I can do a print like invalid number. Please type a valid number. Okay, and then I could also, do another compound declaration to like, yeah, to receive to update these values. Okay, but I'm going to, since we are in this position, I'm going to show you another cool thing that we can do. Because like we did last time around, we're going to have to end up copying this whole thing, right? Because we have to, first of all, we have to call the one before the while loop and one after the while loop. I just lost the stream for a few seconds. Twitch, make sure you're still recording. Yes, I am. Kind of got me worried there for a moment because I thought I forgot to record, but I am recording. Oh yeah, we've been live for a little more. Yeah, we've been live for like 3 hours and 43 minutes. Yeah, okay. So thanks for the reminder. To avoid doing that, we're going to do a pretty cool thing to allow us to control the flow of the program a little bit better. Again, like I was saying, you can read all about control flow here in the documentations, like there's a whole page on that, flow control. Just ways for us to move around the instructions of our program easier. And we want a way to query the user for this information in one place of the code. We don't want to like copy this around to here again, to test, to update the variable is number. But how can we use the variable before it is declared? Because you can't do that. For example, if I move this guy, let's move this guy up here. Undeclared identifier is number. See, so it's saying that is number does not exist. but we are declaring it down here. But why is that? Well, because the thing is, you have to declare variables before using them. There are some programming languages that kind of allow you to kind of use data before declaring them. They put like automatic values in them. But most programming languages that are meant for bigger software don't allow you to do that, because it's very important to know the state of your program in every moment. For example, we know that at this point, this number, everything before it ran properly in terms of like execution, right? So we got the number, we got the variable is number. All of them have the desired values in them. So for that reason, we can't use a variable before declaring it. Remember in the very beginning when I said that the sequence matters? When did I say that? Like this. First of all, we ask it to store the value, and then we add, just like here. First of all, we have to declare set values before using them. Okay? But how does that help you in this point? Help us in this point. I am going to create an infinite loop that's going to ask them forever, because that's the basic idea, right? Keep asking them until what? Well, until is number is true. So if is number is true, we want to get out of the loop or break out of the loop or exit the loop, right? So we have the break from loop statement. The break statement, as you can see here, how it works in code, is a great way to help us control the flow of the loop or change that in different ways. So while true, like we said before, this is supposed to be an infinite loop, right? It's going to run forever. Yeah, but from inside the loop, we can break out of it. For example, I'm going to do like a, here. After the while, I'm going to do a end kind of a message. Okay? That's it. So review this program. I'm going to start the execution here. While true, so forever, I'm going to ask the user to type a number, read the number, and read whether it was a valid number or not. If it was a valid number, I can also do this to be a little bit clear. If is number is true, so if it is a valid number, I'm going to break out of the loop. So no matter the condition, when they see it, when they see this statement here, we're going to exit the loop and break. So what do we expect to see? Type a number. If I press A, it's going to say type a number. If I type an invalid number like this, forever is not going to accept. But if I say like 10, then it says end. So this makes absolutely sure that we have our desired numbers. Okay, and to be a little more clear about the break and continue statements, I'm going to go back to the for example, because it works the same way in for loops, or same way. So we're going to do from 1 to 10. So we're going to do 10 numbers. Then we're going to print the value of the variable it, right, just like we talked before. Then we're going to print a new line. Then end. Can leave the end. Invalid name start. Okay, yeah, forgot this type is match. Print. Okay, so I have print and then print a text, the new line. It's nice to see the errors and how you can read them. That was a little bit too quick. Maybe you can pause and read the error calmly. But the errors are there to help you. So if you read them calmly, you'll be able to solve the problems that you have. So that's a very good tip. Usually people see the error, like panic and like, oh my God, what do I do? I don't know what to do. But if you read that all strings must be closed with the double quotes character in this node, then okay, so I have to close the string. So see, it's really easy. Once you have like use the compiler as a friend and not like an enemy, things like that. It's gonna help you build machine code, which is what you have to do. This is the goal. So the compiler is gonna help you move from this to this, right? So it's great. So let's just see our numbers from 1 to 10. 1 to 10. Perfect. So we are going to control the flow in an interesting manner. For example, if the number is equal to, if it is equal to 5, let's say we break out of the loop, like we saw before. So what's going to happen? What do you guys think is going to happen? Based on what you guys learned about the break, and maybe you guys can play around with it a little bit more, but based on what you saw, it's going to be, first of all, it is 1. So 1 is 1 equal to 5? No, so skip that, continue, print, go back. Now it's going to be 2, 2, no, 3, no, not 4, it's going to be just printing 5. Okay, so is it equals 5? Yes, so it's going to be inside here. It's going to break from loop. So when they find this, it's going to automatically, it's not going to finish the loop, it's just going to break from it. Automatically come back here and continue executing from here. Continue the parent node. So it's going to break out of the loop. So what are we going to see? 1, 2, 3, 4. We didn't even see the 5, because before it printed the 5, it was 5, got in here, broke out of the loop, stopped immediately, and continued. Okay? Continue the parent scope. Pretty cool, right? So there's another way to control the flow of the loop. Let's go back to if statement. I'm going to do like a test if it's equal to 3. Say if it is equal to 3. I am going to create this continue loop statement. Okay, so it's kind of like the break, but the break simply, well, the break stops the loop immediately and exits it, right? Continue will simply skip this execution of the loop. For example, it's going to be 1, it's not equal to 3, not equal to 5, print 2, not equal to 3, not equal to 5, print. 3 is 3 equal to 3, yes, so I'm going to continue loop. It's going to go back here and simply forget about this execution of the loop. It's going to continue the loop as if this execution, as if this iteration just finished. So it's not going to print the number 3, nor test this value. Simply go back and then it'll be 4. Is 4 equal to 3? No. Is 4 equal to 5? No. It's going to print 4. Let's see. 1, 2, 4, end. Because the number 3 got here, continue the loop, so we skipped all that for this execution of the loop and continue from the next one. Break, once they found break, it exits the loop completely. So that's the main difference. And these tools, they are really powerful now, to be honest. You can already create some pretty cool stuff with it. So I strongly encourage you to pause and solve the loops exercise. And there are some pretty cool ones here. You know what? Let's do one together. Let's do the complete calculator 2 together. That's pretty cool. It's pretty complete. Because it's called complete calculator 2. Okay. So let's do this one together. But I encourage you, if you're watching the recorded video, to stop and then solve each exercise individually. And it's kind of an incrementing order, kind of incrementing difficulty kind of way. So this one's going to be pretty easy, pretty easy, pretty easy. We kind of did this one, right? So finish this one. And then we're going to get some pretty interesting ones. It's going to get more complicated. We're going to get some pretty cool stuff. And then all the way to this one's pretty cool. So we have to create this output. Awesome, right? Pretty much like the matrix thing we did earlier. Okay. So let's do the complete calculator. That's pretty interesting. Make a calculator program that receives numbers and operations. It's going to be plus, minus, forward slash, which is divide, star, which is multiply, and caret, which is power of, like exponent, right? It keeps calculating the result until the user's types, well, suppose user types, right? Any invalid operation. For example, it's going to be 5 plus 7. Then it's going to say equals 12. Minus 10 equals 2. To the power of 5, 32. And then you say exit. Now, right now you're thinking, oh my god, how am I going to do that? And let me tell you, you've learned more than enough to do that. And that's pretty cool, right? It's going to be a pretty cool calculator program. Pretty cool, I think. Pretty cool, yeah. So, it can be overwhelming at times, right? But like I said, you have to break this problem into smaller problems. And again, I encourage you to solve these ones first. Then try to solve this one. And there are hints, so you can see the hints. Like, well, if you're not sure how the main loop, okay, you can read all of that. Okay, but I'm going to show you guys how to solve this exercise. together here. So, okay, so we already know what the interaction looks like. So I'm going to read a number and an operator. And another number. Then let's just start doing this thing. Let's not worry about until the exit. Let's not worry about anything. Let's just start typing the very first thing. Then we're going to organize the program as we go. This is the kind of thing about breaking the problem into smaller problems. Like, first of all, let's just do this guy. It's going to be easier than to try, okay, how am I going to structure the whole program? You don't have to know about the whole program yet. The whole program is going to be ready when the whole program is ready, right? For now, all I have to do is to get to know more about this problem, right? So let's just delete the whole thing. Again, I'm going to import IO, because I'm going to use input and output. New procedure, main, which is the entry point. So let's start by creating a new variable, right? Which is like the, let's call this num1, right? For the first number. I'm going to scan int. Oh, this guy has to be a new variable. New variable called num1. The result will be of scan int. I'm going to message. It's going to be, what's that? Just the arrow. Okay, so right now, oops, expression needs to be resolved. Yeah. To a constant value. Oops, yeah, let me show you guys the problem. It says expression needs to resolve to a constant value, but didn't happen in this node. So it said that this node, which is like, this is the expression, this is the declaration, needed to resolve to a constant value, but didn't. Global variables can only be initialized to constant expressions. What does that mean, global variables? Well, if you see, it's actually connected to the global scope, not to the main scope. That means, well, this has a couple of meanings. First of all, this means that this variable is accessible from anywhere in the program, no matter the order. So I've been telling you guys about the order of execution. If it's in the global scope, and that's a language thing, right? If it's the global scope, the order doesn't matter. Like I said, you could like do the main thing and then import later on. You could do things like that. Let's just create like this, okay? This is how it looks in code. This declaration is outside of the main procedure. This means that it can be used here. Let's set num1 to 10. It works. It's valid. We can compile. Perfect. See? But how does that work? Well, because this execution will only happen when the program actually starts. And because this happens before, because it's in the global scope, it's not actually executing. These are the instructions the CPU will execute when you press execute, right? This happens before it. This is like importing the library. This is setting up the stage, so to speak. Well, but because this has this characteristic, you can't like do math here with you can do math like this with numbers you type in, but you can't, if I declare another one here, let's declare var. You can't put var plus 85. Same problem, because it needs to be constant, okay? If it's not constant because it's variable, right? And its value depends on something else, the order of the execution becomes crazy. So, yeah, so maybe that was a little bit confusing. It's okay if it is. It's going to be more evident later on when we talk about procedures and stuff. But for now, let's just go back to what we had, what we meant to have. So I'm going to declare here just for the sake of organizing better. Number one is going to be scan int. Scan, okay, so let's, yeah, again, let's fix the problem, right? This is inside the main procedure. So it's going to be the arrow. Okay, so this is the basic setup. This is how the calculator will start. Start typing a number, 5. End of program. Okay, now we should now ask for an operator. So it's going to be the same thing. Let's try typing text. It's going to call op for operator, declare this operator with colon, and then assign to a scan. Same thing. It's going to be a little arrow. Look at this, same thing, but now it's going to be a string and scan, right? So 5 plus, perfect. Now what does it say? It says that we have to test if it's a valid operator. So it must be plus or minus or these guys. So we could do something like if, for example, we could do like a giant OR here. So if it's if op, let's do equal, right? If op is equal to plus, or op is equal to, let's do the op thing again, op is equal to minus, and we can do all of them here. This makes sure that this will be executed if all of them are true, or I mean, if it's a valid operation, and this is a false operation, right? We could do that, but we need to operate on the number, right? We need to receive another number, and then see the result. So we need another scan int inside of this like this, but it'll be 2. So if it's a valid number, I'm gonna read the second number. You're starting to get the structure of the program. See? One thing at a time. Let's just finish this guy, writing all the operations. I'm gonna copy the text. It's gonna be easier. So if it's plus, minus, divided by, times, or the caret. Oh, we have to organize this. Oops, that was kind of a little bit of a failure. Okay. Okay. So yeah, it kind of created this cascading structure, which is kind of okay, I suppose. We could also do the same thing we did before, which might actually be easier to read, which is like this, and then we do like these pairs. Yeah, that's going to be better. This is simply the order that we are creating the tests, but it doesn't even matter because see the parentheses changed, like we're doing these guys first, but the OR is going to work the same way. If either of these guys is true, we're going to be true, and we ask the other one. If it's false, we're going to print exit. So print exit. Okay, so let's start see the how it works. So 5 plus, then it asks for another one. Let's say 7, but then it exits. Okay, so we're starting together. Now, before we do, we need the result, right? Either way, we need the result. So the result will be, well, it depends, right? That's the thing. If I set a plus, I have to get this guy and add it to the previous one. So instead of just doing num1, I can call it result. Okay, and this is like, let's call that new num. Okay, and then I'm gonna do a new test, like if op is equal to plus, then result. Oops, result will be what? I could do like this that we already did. Result will be equal to what is already in result. So result equal to result plus new num. Or we could do the other thing that we learned, which is the plus equal operator. So plus equal means add and set. So we could do the add and set. We're gonna add and set new num. Same thing. If it's op. But if it's not op, I have to test, oh, if it's not plus, right? If it's plus. If it's not plus, I have to test if it's minus. And this creates a very interesting structure of the code. So if op equals minus, so if you typed minus, I can pretty much do the same thing here, but with the minus thing. So look at this structure. Pretty cool, right? So I typed a valid operator. Then I read a new number. If that operator is plus, then I add that to the result. If the operator is minus, then I subtract that to the result. And this creates a else if kind of scenario. So this if inside the else here will only run if this condition is false. Another way you're going to see this written in a lot of code is like this. Same thing, else if. So if this is true, run this. If this is false, run this condition. It's the same thing. See, the nodes didn't change. The nodes are still the same if you write it like this, or if you add these guys. It's the exact same thing. Test this condition. If it's true, do this. If it's not true, do this. Test this, I suppose. Test this. And if that's true, test this. And you can keep doing that. Like, okay, if that's not true, else, then test if op equals to multiplication. Then we do result times equals, same thing, to a new num. And now if this guy isn't true, same thing, else if op equals divided by, maybe divided by, if it is, we're going to be result divided by new num. And if you're having a hard time following this structure right now, take some time to do the previous exercises, okay? Because that's the thing. It only means that you haven't got accustomed to the flow of the programs, right? And this program is a little bit more advanced, but it tests your skills. So that's why you have to do the other exercises first, right? Okay. And this final else, let's see here the structure. If it's plus, do this. If it's minus, do this. If it's times, multiply. If it's divided by, divide by. If it's not, well, the other one is the power of. Okay? We're just going to print power of, because we're going to do that a little bit later on. Power of. Okay? Okay, so in either case, so even if it's plus or if it's minus or whatever, so after doing all these ifs and testing all that stuff, now you can print the result. Okay, so that's the basic structure. I'm going to organize the nodes in a while. Let me just print the result. Okay, compile and rearrange the nodes. See how it went way back here? This is how it looks. It's going to be a little bit more organized if you see it like this. So try to compare both structures of the programs, and that's pretty interesting. So main here, everything is inside its block. Okay? Okay. And then it does like the first read, and then this guy, this operation, right? And then test, oh, if it's a valid operation, do this, which is like reading another number, and test if it's plus, sum. If it's not plus, again. If it's plus, sum. If it's not plus, else here. Test if it's minus. Then test if that's not true, test this, okay? Do all the operations. But after you test, and we already know that it's a valid operation at this point. So after we do the tests to see which operation is it, we simply, after all that, print the little arrow in the result. See how that looks? After this if gets closed down here. This is the valid operation. This if, which is which operation is it, ends here. And then there's the else, which is the for, which is the false, I mean. It ends here. Okay? And then you see the result. Let's test the program and really try to understand it step by step. Like, first things first, what am I going to do? Well, when it starts, it's going to ask me for a number. Easy as that. So I'm going to type 10. Then it's going to ask me for an operation. So I'm going to type like plus. When I press plus, it's going to test, is plus one of these guys or one of these guys? Yes, well, if they are, I'm going to ask for another number. So they are, ask for a number, let's say 5. I say 5, I'm going to say, okay, so now let's see the specific operation. Was it plus? Yes, so, oops, what's that? It's going to add this new number to what was in result. So it's going to add 5 to 10 and then set the result, add and set. It's going to add and then set 15 to the result. After that, it's going to go back and then finish the parent's execution, which is printing the result. Finish this guy. Let's finish the its parent execution, which is this guy. It's going to just say exit. Okay. Oh, it's opened. Oh, yeah, I was already running it. So I said 10 plus 5, 15, and then exit. Awesome or what? First of all, let me just make it a little bit more awesome by printing a new line here. Oops. Print new line here. Then let's try 3 times 10. 30, exit. Perfect. However, it's not done yet. The calculator is supposed to keep, it's not arrow, it's supposed to be like this guy for the result. It's going to be easier for the user to see. So 5 divided by, 2. It's going to be 2. And there's a rest of the operation, the remainder. But it doesn't include here because it's a whole number. We are doing ints. We can't have decimal places in integers, right? So 5 times 2 in integer is equal to 2. Then exit. Perfect. Now, that's not what we want. We want the whole thing to be repeating. So after we set the result, so let's see 5. Oops. See, I typed an invalid operator, so you just said exit. If I do like 5 plus 6, 11. So after we print this guy, we want to go back and ask for another operator. See, so this is the point where we want to repeat. We don't want to repeat this guy because we already have the result, but we want to repeat the operator. Let me just show you guys here in this code. So this structure, we want to repeat. We want to get another operator. We're going to test if it's a valid one. We're going to get a new number, then add and set inside the based on the operation. Then it's going to set the result, and then it's going to try that all over again. So instead of just doing this once, remember what we already learned, I'm going to do that inside a while loop. A while true loop. So this is it. It's connected to the loop part. So this is the basic structure. First of all, I'm going to read one value, and then forever, I'm going to read an operation, test if it's a valid operation, then operate on the values, set the result. After this is done, it's going to go back to the parent scope here. Then it's going to, exit. That's not right. Because we don't want to exit after this. We want to exit if it's a false operation, right? If it's an invalid operator, like if we set like instead of plus we set like something else, we can print exit, and then we're going to break out of the loop. Break out of this while loop. So the breaks can be whatever you want inside of the loop. This case is going to be perfect, like this. So let me rearrange and show you guys again. So again, the notes got down here to represent what it looks like in the text. See, because the text shows like, okay, so these breaks down here are in this else's represent this if. Same thing you can see here. You can follow the line to this if. And this means that if the operator is not valid, so if the user typed an invalid operator, if it's not plus or minus or slash or equals or caret, it's going to be power of. If that's false, it's not either one of them, then we're gonna print exit and break out of the loop, finishing the program. Okay, let's try a little bit more. So 5 plus, let's do 6. So when I press 6, I'm going to get a new number. I'm going to see the plus here. I'm going to add 5 plus 6, it's going to be 11. Result will hold 11. Then it's going to finish this guy's scope. So it's going to print equals 11, new line. So it's going to finish this parent's scope, which has nothing. So it's going to go back and continue the while. It's going to do another iteration. So it's going to ask again for the operator. Okay? Perfect. 11. Now what you have to do with 11? That's minus 1. Now it's 10 plus 5, 15 times 10, 150 divided by 50. 3 minus 2, 1 plus 1. So we have a pretty much awesomely functioning calculator at this point. We don't have the caret yet, so if I do the caret, it'll simply and I do caret like 2, it'll simply says power of, because I have to finish implementing that. Power of. Okay? And then we'll break. And then we'll ask for another operator. Okay, so that's pretty awesome, to be honest. And if you manage to understand this program and maybe recreate that, you are well off your way into programming, to be honest. You know, this course, you know, of course, we've been 4 hours in the course. But even given that, well, and if you did the exercise in practice, certainly more than that. But in terms of content, right? This is a very cool program that you are able to build, right? If you didn't understand it, it's okay. You can go back and rewatch, or you can try the easiest exercises. And all with the hints. The hints really help you. If you see this exercise has pretty cool hints, you know, very detailed explanation with pieces of code that you can copy and see. See, at this point, it uses a different methods of returning. Like I said, there's tons of ways to create this. You don't have to do my way. You can always do your way. As long as you're comfortable understanding and the program executes robustly, that's important. Okay, so we have the basic functionality. Now let's finish doing the power of thing. So what is the power of? How do we let's say we have like 5, which is like the base, and let's say the exponent is 3. How are we going to do the result of this operation? Well, it's pretty simple. We're going to repeat we're going to multiply 5 by itself 3 times. So it's going to be 5 plus times 5 times 5. Easy as that. So we know what to do in terms of algorithm. So that's a word that's going to hear a lot when you're talking about programming, algorithm. An algorithm is simply a series of instructions that one follows. For example, well, to find the power of, to find, well, this exponent operation, right? We'll simply multiply 5 times itself 3 times. So multiply 5 times 5 and then again. That's the basic algorithm for solving this problem. Now let's implement it in code. So we have the base. The base is the result. And we have the exponent, which is 3. Now, we want to do something like 5 times 5 times 5, right? So we have to repeat something this number of times. How can we do that? How can we repeat some part of the code, like multiplying 5 by itself, this number of times, the number of the new num? Can you guys think about a way? We can use the for loop. And like I said, we are inside of while loop, we're inside of if. Everything cascades, because everything you learn builds on top of previous knowledge. That's why it's important to really consolidate what you're learning before you go to new things. So the for loop is going to be great for this. So I'm going to repeat, let's say in this case it's 3, so I'm going to repeat 3 times. So I'm going to go from 1 all the way to new num. So new num will be the exponent. If it's 3, it's going to be 1, 1, 2, 3. It's going to be 3 times. 3 times, okay? So that's the basic idea. And what are we going to repeat 3 times? Well, I'm going to show you guys something and then you can tell me if it's right or not. We could say simply result times equals, connect, result. Because result is the base, is it not? Like 5 times 5 times 5, but there's a problem. Let's try executing this part of the code right here. So let's say 5, let's say a result is 5, and let's say new num is 3. Okay, so we're going to do 4. We're going to repeat 3 times. Repeat 3 times. So first time, we're going to do result time equals result. That's the same thing as result will be equal to 5, right, times 5. Perfect. That's the first part. Well, it's kind of wrong because it's going to repeat 3 times. There's nothing. Let's go a step. Let's try execute the program in the paper first. And that's another great tactic that you can use to solve problems that you're having a hard time on. look at the code, and before trying just running and guessing what's right and then playing around with the code until you get the right answer, really try to understand what will happen when you execute. So, okay, so the second time, again, it'll be result times equals result. That's what I wrote here, right? I can also do it like this if it's easier for you. Same thing. So it's going to be result equals to the result. The result at this point is not 5, it's 25 times 25. So it's going to be way off, 625. Why? Because it should be 25 times 5. That's what we expect. See? We expect it because the base can't change, but the result has to change. So how do we fix that? Well, it's really simple. We create a new variable. I'm going to call that base. And we will have the value of new num. And at this point, the result will simply be the value itself times the base. So let's compare to what we're doing now. Now we have, again, we have result and new num equals 5, and then we have base that equals to new num. So it equals to 3. Oh, this is wrong. See, when you type it, it's wrong. It's supposed to be the base, it's 5. It's the result, it's not the new num. See, it's great to actually know what you're doing with the code. So I hope you actually understand this kind of a thing. It's kind of just a side note. It's a rare thing to see. Because when you're watching a tutorial, you're usually going to see a very kind of a step-by-step thing. But when you're programming, that doesn't happen. You have to solve your problem, right? So yeah, so this is the really valuable stuff that I think you can take away from this course, right? So result times 5. New num, result is 5, new num is 3, base is 5. Okay, perfect. Now again, for repeat 5 times. First time, the result will be equal to result, which is 5, times base, which is 5. So let's just repeat this whole thing here. So result now 25, new num is still 3, base is still 3. So second time, result will be 25 times 5, which is the base, which is 123, which is the result. And the thing is, we don't need the third time. That's another problem we have. Because 3 times we are multiplying, but actually it's 5 times 5 times 5. The actual operation, like this operation here, is only happening twice. 5 appears 3 times, but the 5 is already here. So we can do like, we can also do 2. We can start in 2. It's also inclusive, like the random thing. Or we could do like 1 and do like new num minus 1. That's also a common way you're going to see. Oops, not negate. Negate will make, if it's like positive 3, it's going to make it minus 3. That's negate. I'm going to do subtract. So it's going to be new num minus 1. So if it's 3, we're going to repeat 2 times. 1 and 2. Because it's going to be 3 minus 1. Okay? Oops, I don't think you guys saw the very last thing there. There you have it. There you have it. Result, wow, we still don't see it. See, now we see. Result is going to be 125. New num is going to be 3. Base is going to be 5. We don't really care about them, right? Okay? Now let's compile and run the program. Let's do 2 to the power of 5. Should be, I'm not sure. Let's do to the power of 10, which is 125. 1024. 1024. So we have our power working. Let's do that minus 24. Oops, got that wrong. Again, have to do the operation and then enter. So minus 24, awesome, divided by 100, it's 10. Let's do 10 to the power of 3. So it's 1,000. Awesome. Let's do 1,000 minus, I don't know, 600. Oops, I always got that wrong again. Minus 600. And then let's just end the program. Awesome. Or what, guys? I think you guys managed to learn a lot with these example, right? Awesome. Awesome, awesome, awesome. Just a quick note that I want to show you about scopes, because we talked a little bit about global scopes. So I'm gonna you could save. I'm gonna delete the whole thing, but if you're creating that by yourself, it's probably a good idea to save each one in a different project, like we saw in the very beginning, so you can refer back to them later on. But I'm just going to delete the whole thing because we have to move on to new things, right? I want to show you something interesting. So I'm going to create the main procedure here. Main procedure. I'm going to create a variable. Let's call that variable. Let's call that variable A. And we have an if statement. Let's just say if true. If I have a new variable B here, I can set the value of B to be A. Awesome, right? Because I declare A here. If it's true, and then B will be equals A. See here? Pretty easy. Right, awesome. Yeah, that was pretty cool. That was a pretty big program that we managed to create. I hope you guys understand it all. That was pretty cool. Thanks for the comment. Okay, I think you guys got this flow, right? However, if we create a new variable down here, let's create a new variable. Oops, not a new procedure. A new variable. Let's call that C. C, let's say that C equals A. Okay, let's compile. It's still compiling. Perfect. Because A exists here. We declared beforehand. Okay. But if we say that C equals B, what will happen? It says undeclared identifier B. But what do you mean? We declared here. It happens before it, right? Yes, but there's a slight problem, and it has to do with the scope. The scope, represented by these white lines here, these continuous white lines, start out with this curve and then goes on, or with the curly brackets here. So the curly braces, yeah. This is the scope, starts here, ends here. This is the scope, starts here, ends here. Same thing in the code. This is the scope, starts here, ends here. See, same thing. This scope starts here and ends here. Okay, there's a little mosquito here. Okay. Perfect. Now, when the scope closes, like this or like this, and it goes back to the parent scope, and it continues from there, all identifiers, all variables created inside that scope goes out of scope, which means that they are destroyed, pretty much. They are destroyed. So if we go back to our memory example, another way to visualize this is vertically. Like, I'm going to call that a stack, because the first variable we create, A, down here. Oops, down here, A. Then we get inside this scope, this other scope, right? And add B. But when we go out of the scope, here and here, and go back to this scope, we delete everything that was created inside that scope in terms of variables and stuff. And then go back to here, and then we create C. So C doesn't know B because B went out of scope. That's a very important thing to note and to understand when you are declaring variables. Like, if you want to use, for example, a very common thing to know, it happened in our previous example, right? We have an if, and that if, like, oh, if this is true, I'm going to, like, yeah, I'm going to do this example. Like, if this is true, B is going to be equal to A. If this is false, B is going to be equal to A plus 2. Just for another example. going to be a plus 2. Okay, so look at this. We have now 3 scopes going on. We have, okay, see, we have the main procedures scope, have the if true scope, and have the if false scope. This guy, and this guy. Okay, now we can't use the value of b out here. See, we can't use because it's all out of scope. We create it and then it goes out of scope. So a very common pattern you see when programming is, for example, to pre-declare a variable, let's say b, and we don't even need to assign it to anything. Just need to create, let's say, an integer value. And then here we set its value, let's say set b to be a, and it says there were 2 b's because we have kind of 2 b's here, and that's a problem. But it's going to go away. So we're going to set b to the value of a plus 2, and here we're going to set the value of b to a. And then here we can use b because it was created in the same scope or in a previous scope, in a parent scope. Okay, here's a little bit more organized. So b is being declared before, so it can be used inside the scope because it was declared in the parent scope. And then here we use the value of b that changed based on some random condition. Okay, so I think if you don't understand the whole mechanics of it, it's not very important, but it's a good thing to note when you're programming why you may not use certain variables, you know, because you have to think about the scopes. The global scope's the big exception, because if I create a variable here and call that like z, for example, and this particular thing about global scopes depends on the language, so that's a bit of a caveat here. Okay, so this is how it looks, right? I have the main procedure and its scope and the z. Again, I said that you can use values of the scope and the previous and the parent scopes as well. So I can use like b and a here, but I can also use z. So b could be z here because it belongs to the parent scope. And if that scope happens to be the global scope like we saw before, the order doesn't matter. So it's ordered independent declarations. We could declare z here, we could declare z here. It's all the same. You can still use it anywhere in the program. And it's not ambiguous, the value, because the value is always constant. Because you can imagine that if you had this problem of declaring like c before b or after b or before this if you just change this, the c to be before or after if, b is going to be totally different, right? Because this will be executing before or not. This doesn't happen in the global scope. So that's a good thing to note in terms of scopes. Okay? Okay, hopefully, by doing this exercise together, we managed to create some cool programs, and now you can go ahead and finish the other 2 exercises. So we can learn, there are 2 more things that I want to show you guys, 2 more major things in this course, because after all, you are really supposed to learn it's a full course. It's not like a fake course. It's a full course. Okay. So let's do this. Transforming lots of values. I'm gonna show you guys, and you know it was already hinted in the beginning of the stream because someone asked what was that. So I'm gonna show you guys about this cool button here. This button transforms this variable to an array variable. What is array? Let's go back. Let's go back to our drawing board here. And okay, so I said, okay, there's tons of different kinds of blockers and stuff. One kind of blocker that's pretty cool is an array, which is when you have lots of values of the same type that has some kind of connection to you. And okay, what does that mean? For example, if I'm reading like 10 numbers that we are supposed to be operated on in the same fashion, I could create 10 individual variables and do like one plus the other and things like that. But it's going to be really hard, especially if it's a lot of numbers. And believe me, computers deal in lots of things. That's why they're good at operating, right? Because they can do a lot of stuff. And that's awesome. So I have to make it easier for us to operate on tons of data. And arrays is one of the ways we can structure this data. That's why it's called a data structure. that's very easy for us to iterate through the whole thing and operate in tons of different values of the same type in the same way. So var is now an array, right? Like reading this, but array of integers. This is the size. Like, okay, array. There are different kinds of array and stuff, but for the sake of this course, an array has a fixed and known size. So there are different kinds of array, like I said, and stuff, but let's talk about fixed size arrays. Fixed size arrays. We have to tell the compiler, when we compile, right, the size of the array, so that the size of the locker can be known to the compiler, so we can reserve that locker. If you know the size, how big would the locker be? It doesn't know. It has to know to create these kinds of variables. So let's say it's 10 integers. Let's compile. Okay. Now if we try to print, oops, let's turn on context. Try to print. Oh, I forgot to import print, so we can't print. Oops, not this. Print. Perfect. Now if we try to print these values as integers, var, let's compile. Type mismatch. In argument 1, value of procedure call in this node. Okay, so there was a problem in type. Wanted int. Found this guy 10 int. See here, 10 int. That's the type. The type is 10 array of 10 ints. And we can see the declaration, right? So that's the problem. Because this guy is not an int. It's a ton of ints, 10 of them. So we can't simply print 10 ints at one time if this is expecting one int. What can we do? There are two pretty cool operators to use with arrays. One of them is called array subscript. And then I say an array. Then I pass an index. And this index will index the array at this position. For example, if I want to see the first position of the array, I can index this array at position 0. So I'm going to draw this for you guys. So arrays, so let's go back here and let's say arrays. Arrays. Okay. First of all, we declare them. So the compiler reserves a fixed size of a locker, of a variable, right? That contains, let's say, 1, 2, 3, 4, 5, 6, 7, 8. 8. Let's say it's 8 ints. Now, so this is the first one, second one, third one, etc. For reasons that I'm not going to get into now. But makes sense, so you can trust me on that. When you're indexing an array, the very first position is always 0. Second one is going to be 1, and then 2, and 3, and 4, and 5, and 6, and then 7. And that's kind of interesting because we said we wanted 8 elements, and we got 8, like 1, 2, 3, 4, 5, 6, 7, 8. However, the last element is not element 8, it's element 7. And that's the source of confusion for a lot of people, especially beginners. So, just want to make clear that when you're dealing with arrays, the very first one is at index 0. So, when we use the subscript operator to index an array at a certain position, we should use these indexes. It's like the first one's going to be 0, the second one 1, third one 2, fourth one 3, etc. until the last one is going to be the total size minus 1. We're going to see in this case like 8, which is the total size minus 1, 7. Okay, so right now, let's just compile and run. We see 0. We see 0 for a very specific reason. Some languages, when you just declare things and don't assign, see, only has the colon. As of now, let's create a var2. We've been creating things like this, where it's a declaration and an assignment. But if we don't assign, we just declare an int. We don't set its value, right? We can do that. It's okay. That's the other way to do declarations, right? Just declare it. And you can also do the assignments afterwards, like this. So you're explicitly saying that this is an integer that equals 35. But it's the same thing as not doing the int and leaving that implicit, as an implicit type, okay? But the point is with the array where we're creating a value. We're not setting the value, right? In this language, and that depends on the language that you're using again, when you don't initialize a variable to any value, it's initialized to 0. So when you ask for array, or when you ask for integer value, when you ask for whatever, it's always 0. In terms of when it's a text, it's empty text. It's not 0 text, it's empty text. But in this case, it's 0. That's why we got 0. We're going to get 0 every time. And this changes from language to language. Some languages will give you junk, like whatever was there back in the memory. So it's also something to keep in mind, like, are you going to print the value before setting it? But now let's work about setting arrays. Like I said, arrays are great because you can very easily set them. I showed you guys how to repeat something a number of times, like 10 times, like we need now. For example, with a for loop. We use that a couple times. So, and the good thing about for loops is that you can tell the iterator right here. But by default, it goes from 0 to a number, let's say 9. And in this case, it's like pretty much perfect. We want from 0, which is the first, the last one, in this case, is going to be 9. Right, so the first one's going to be, again, let me just finish writing this array, let's say array of 10. It's going to be 8 and 9. 8 and 9. Okay? Oh, that's a terrible 9. You got the idea. And now if, for example, we print int, we're going to print what? We're going to subscript the array var at the position it. Okay, so we're going to print the variable that is inside the array at the position it. So we're going to print the first one, position 0, then position 1, position 2, position 3, all the way to position 9, which is the last position, the 10th position. I'm going to print all of them in sequence, so I'm going to, print a new line. Perfect. Oops. We get 10 zeros, printing the entire array. So with for loops, it's very easy to iterate through entire arrays. Super easy. Let's create another for loop here. And as you can see, you can just copy the syntax from the previous one. And now let's set the value. And the same thing is the set, just like we saw with getting the value or printing it. We can use the set node, but if you try passing the array here, let's try passing the array. It automatically actually creates the subscript for you. So I didn't even remember that we do that. That's pretty cool. So if you try to set the array directly, you can't do that. You have to set that at a specific position. So let's set the array at position it. Again, it's going to run from the very first one to the very last one because it's size 10. And let's set, let's import random. Let's do that really quickly here. Oops, not this. Not procedure, library, random. And then let's add a random int in range. Let's do from like 0 to 100. 100 is okay. Okay, let's compile. And then what we're going to do, first of all, we're going to set 10 values. We're going to run through the whole array 10 times for each value. We're going to set it to a random number from 0 to 100. And then we're going to print the number. So we're going to iterate 10 times again, printing the value in all the positions. Okay, then printing a new line each time to be organized. So what do we have? We have like 10 random numbers. 18, 89, 99. Perfect. And if we run again, we have another set of numbers. And look how easy it was to iterate through all those numbers. And the thing is, if you want like 1,000 random numbers, it's going to be just as easy. For example, I'm going to change that to 1,000. But if you notice, if I change that to 1,000, like this, I'm also going to have to change all the for loops. And it was pretty close in only three places here, but you can imagine that it can really be prone to error. Like you can forget that there was a for loop somewhere that used the number. So we're going to talk about that in a second. Let's just test the program. So yeah, there was a lot of cool random numbers. We're going to do cool stuff with it in a while. Okay. Okay, perfect. So yeah, about this guy. this guy, it's arithmetic. Remember, we call that literal numbers or hard-coded numbers because its value is fixed inside the code. We can use a pretty cool thing, another operator, like I said, that was the array subscript. There's also the array count. The array count gives us this number, this 10 guy, or this guy, 1000 now. So instead of typing the last index, which is the array count -1, we can just type the array, which is var dot count -1. Let's see how it looks here. So it's the array. You add the count node like this, array count, and then you subtract 1 from the result, -1. That's it. Same thing will be here. So, and if I add the array, it automatically add this whole thing for us. But you can do manually as well. You can do like count. Oops, turn off context. Count. Then I'm gonna do -1. So now if I change back to 10, it'll automatically work perfectly. If we do like a lot of numbers, I'm just gonna do a lot of numbers. And just as a cool side note, what do you think will happen? Oh, it's gonna take a long time. What do you guys think will happen? Just because it's taking a long time to print, not calculate. It's not actually a lot of numbers, but to print that, the console is pretty slow. What do you guys think would happen if I try to run through like a lot of arrays, more positions that I have in an array? Like I ask for this much, what happens if I try to index the array at this position? What do you guys think? Let's see. What could that be? That is a program crash. You probably saw a program crash before. Like you were working and then the program stopped working. Maybe it just froze, or maybe it froze and disappeared like this, or maybe it crashed. It became unresponsive. One of the problems that happen, and that's a very common problem actually, is when you try to access memory that's not yours. Remember that this whole thing, this whole locker is memory? If you asked for this much, but try to open this guy's locker, the operating system, like Windows, it's not going to let you do that. So it's going to crash your program. So this is what happened when you asked for 10 and got and tried to do a lot more. Okay, that's something to keep in mind, not to be careful. So that's why using things like this is very good. And there are some cases where we'll be able to, the compiler checks that for you, like, oh, maybe I think you're trying to index an array out of bounds. That's the term. So it can help you in those cases. Okay, so that is everything you need to know about arrays in terms of functionality. Now, the cool thing about arrays is just like everything we showed you guys, are the possibilities that they open up. And there are so much that, see, there are tons of exercises that I'm going to leave this as a challenge for you. Okay? The challenge will be to follow this, and you're dead certain to start, and this guy, you're gonna breeze through this one. And maybe this one as well. Okay? There are a couple of traps here. But the thing is, these guys are going to show you some really cool programs, like the ones we did with the calculator too. These ones are going to be really cool as well, but it's going to take a while to create them. So you have to be patient and just review the video and review the concepts and see the hints. It's going to be awesome. Okay? But there's a final thing that we kind of brushed through in the beginning, and now I'm going to formalize and tell you guys what it is. That is kind of a little bit of a different thing. Because as of now, everything that we learned so far opened up the possibilities in terms of creation. Like the if statement can change the kinds of programming we can create. Although this happened to an extent of this new feature I'm going to show you, it has a different benefit. For example, first of all, we created the main procedure. Like, we created nothing, right? And it was like, okay, empty code, you need to add nodes. Then we added like a new procedure. It was like, okay, good, but I need a procedure called main. And like, okay, main then. And then we got the program compiling for the first time. Okay? Now, we used import library to import things like print, and then IO, and then random. And then you can use cool things like game engine to create games. Alright? But those libraries simply give you tons of procedures. But you can create procedures yourself. And like I said before, procedures are great because they allow you to focus on a specific problem. It could be something like very generic, like printing a message to the user screen. Or it could be more specific to your program. Like, remember when we did the calculator and we had the power of? Maybe we could do a procedure that creates the power of. In fact, we're going to do that. It's pretty cool. So we can call that multiple times. For example, let's say we have a procedure. Oh, let's go back and import print. Let's import IO, to be honest. IO. Let's say we could put things like while loop to stop using code multiple times. But sometimes you really need to duplicate code, so to speak. So let's create a variable called var. I don't know, it's like 5. I'm gonna say that var. Var is gonna be equal to, so set the value of var. Let's say that we're gonna do same thing. We're gonna do the base and the exponent. Base is gonna be 5. New var, exponent, xp, maybe 3. Okay, and then we could do the same thing we did before to calculate the power of 5 to the power of 3 thing. We could do that pretty easily here. But let's say somewhere else after an if, in the beginning we were kind of lost in the program, there are tons of stuff. We need to do that again. So we would have to duplicate the code pretty much the same way. So I'm going to do the for, like we did before, for 1 up until, it was 2, right? Up until xp. We're going to do base. Well, we should also have the result, right? So no variable result is equal to base. It's going to be times equals base times equals result times equal. Yeah, we already did that, and after all I'm going to print int the result. So it should be 125, and it is 125. We already did that. Thing is, if we and that's kind of not a big code, but you kind of saw the problem, right? If we need to do this every time we need an exponent in a program that uses exponent all the time, it's kind of a problem, right, in terms of productivity, and it's gonna pollute the code. Like, let's say there's an if statement here, true, then there's like a while loop, true, and there's like an if, then if true, or if false, break, whatever, just to show you some more complicated code that can form, like you saw, like we did this program before, more complicated program in terms of like flow, right? And then right here in the false, we could have another exponent. Like we could have like, okay, so now I have another number, and this time's like 2, and we need 2 to the power of 10. So I'm gonna duplicate this whole thing to print these guys. But I can't create result because it already exists, so I'm gonna do like result underscore just to create a new name for the variable. And then the xp already exists, but is a different value, so I'm going to hard code that to be 10. So it starts really messing up the program. So that was kind of a long explanation as to the main purposes of procedures, is that encapsulating ideas that are self-contained and can be repurposed. Okay, so let's do a procedure called not factorial. We could do a factorial as well. That's pretty. I'm gonna leave that to you. But we could also add factorial to that calculator. That's pretty cool. If you have the project and didn't delete it, try adding a factorial to that. It's a pretty cool exercise as well to make sure that you understand calculations and loops and stuff. I'm gonna do a POW. It's usually called POW on math libraries for power called pow. And just like and let's delete this whole thing. Let's say we just want the result, really. You want the result, and we want to call pow like this. Same thing we did with the scan, and then it gave us the value, right? So these, and like we could just like add procedures like we've been doing with the main, same thing. And calling like we did with the print, same thing as well. So that's the basic setup. I can, when print starts, right? So this is the program entry, right? So the program is going to execute this. It's going to execute what? This procedure. So let's run this executions code, print hello. So it's going to print hello. Okay, if I call that twice, it's going to be hello twice because it's going to execute this guy. So when it gets to this one, it's going to run this function's body, which is going to print. Then when it finishes out of scope, it's going to go back to the scope where it was. Going to run again, call this procedure, come here, run the print. Okay, these things you already saw, right? And you can kind of do things like if you had two prints like this, maybe this one has two new lines at the end. It's gonna call hello, 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 right? Because we're calling pow. It's gonna print these two guys. I'm gonna call it again, print it again. Okay, and you can already kind of see the possibilities, I suppose, right? You can start thinking about how to organize your program way better, in a way that you don't need to do like the whole thing straight in a sequence, but you can jump around to code, repeat code without typing it again or without duplicating the nodes, things like that. Okay, but like we said, the pow function needs to return a value. See, return here. So this is what we're going to do. We're going to return, and the only option we have in the context is a new variable because that's how we specify that we're going to return a value. So let's say we return, let's call that result. And the type is going to be auto 0. So that's the basic idea. As you can see, this is what the syntax looks like. We have this little arrow, which means that we are outputting this value. It's called our result and equals to 5. So right now, equals 0, I mean. And right now, it already appears here. So pretty much like the scan procedure, let's turn off context. It has a value here. Okay, and we can specify int, and maybe we can give a default value or not based on what we want. Okay, and then we have the result. But we also have to pass the base and exponent, like we do, for example, with the print procedure. We pass a message, or the scan procedure. We pass another message, right? For that, we use parameters. Parameters are values that the caller passes to the procedure. Easy as that. So I'm going to come here, turn on context switcher again. I'm going to create a new variable. I'm going to call base. I'm going to create a new variable and called xp for exponent. Okay, and there's a problem. Okay, for some reason that was print. I'm not sure if I typed that. Oh, yeah, this was selected. Or something like this, and then I typed print here, and it got here. I forgot to like click the mouse button. Yeah. Interesting. So right now, again, look at the pow call. Now the pow call, the call to the pow procedure. It has base and exponent, and see that these values grayed out, like we saw before with the print. It has hello grayed out. That's because we set the default value to be this guy. If we set the base like 2 and the exponent to 10, these will be the default values now. We could also change that like 3 and 3. And we can call that again, like pow, we can call like 5, 3 as well. And see how that looks in the text code. The declaration involves pretty much like a variable declaration. That's why it's pretty much the same thing. See? And then you use comma to separate the different arguments. And you can also return multiple values. like we saw with the scan procedure. So what we're seeing now is how to create what we've been using, right? Which is pretty cool. Okay, but how do we actually operate on these guys? If we get a node out here, and let's do a set, for instance. We can set, we have the base and the exponent. So these guys, they're just variables. They're just variables. They have either their default values or the values that the caller passes to us. So they're pretty cool. So we can operate on them normally. The return is not a variable. That's why it's kind of a little bit grayed out here. It's a little bit of a darker shade of gray. The POW procedure, oh, I'm sorry. That wasn't what I meant to say. The result, let me go back to the set. The result does not exist in this context, or any context, to be honest. Why? Because it's not a variable. It's simply a name with possibly a type and a default value that we can use only when we return the value. And that is the last thing I'm going to show you today, which is the return statement. Okay? So the return statement is a node that says, okay, I am going to exit this procedure I am in, possibly returning values. So, for example, I'm going to return the result because I specified it as a return value, so I have to tell it the result. If I had a default value like 5, it would use the default value, but I could override it, just like we did with the parameters, right? Let's say no default value, and let's say 5. So this procedure, whenever it starts, is going to return the result value of 5. So right here, what's going to be this guy? 5. If I print int, oh, I forgot to include print. I did. Oh, I didn't. Let's print. Let's print int, and then connect it here. Oh, just a side note. As you saw, if you don't use the return value, you simply connect the node like we've been doing before. But if you do use, you connect that to another node, and that node is the one that's going to use going to connect the execution node. So you can't connect an execution and a return value because the execution will be guided by this node. Okay, this is just a side note. Okay, unconnected node. Oh, for some reason I have I/O very far away. Oh yeah, I unconnected it. Yeah, when I created the print. Okay, perfect. Now, what should we print? We shouldn't print the result of 3 to the power of 3 because we're just returning 5 here. So we just see the 5, and we see just the 5. If we say 10, 10. But now is where things get interesting because we're going to create an actual functionality in this procedure. So I'm going to create a new variable like we did before called result. It's going to be the base, not the vase, the base. And then I'm going to do for loop, start 2, going to be all the way to the exponent. And I'm going to do that times equal operation that we did, result times equal the base. And I'm going to return result. Okay, should be familiar with this kind of working this way. I kind of typed a lot. I could have connected like this. Same thing, but it was a little bit faster to type. Now, whenever I call the POW function or procedure, like I said in the beginning, you can use them pretty much interchangeably. They mean different things in very specific contexts. That's why I try to call them procedures. But if I slip a function here and there, I'm meaning the same thing. When I call it, it's going to come here, pass 3 and 3, so go here, start. Result is going to be the value of base. Base is going to be 3 because I passed 3 as the base. So 2 and 3, so I'm going to run this once. Is it right? No, twice. 2, I'm going to run 2 and 3, 2 times. And then I'm going to, result's going to be result, which is the base, right? So 3 times 3. Okay, then run again is going to be 9. 9 times 3 is going to be 27. Then we're going to return to the caller the result of result, which is 27. 27. Perfect or what? And the great thing about it is that we can now call it in arbitrary things. Like, let's copy a couple times. Let's do like 2, 10. Let's do 5, 5. Oh, forgot a parentheses there. See, this is the kind of thing, like forgetting the parentheses, that doesn't happen when you do the visual notes. So yeah, that's why they're really great. Oh, I have to add a new line as well. You could add a new line here, depending on how you expect this to be called. Like, if every time you need the POW you want to print, you could just print it here and just call them and not give them a result. But if you want to work with the result, like setting it to a variable, maybe you want to be more flexible. So that's why it's important not to think too much about the procedures beforehand, and kind of see the patterns that emerge in the code. Like, it looks for, I don't know if that is the correct number, but I'm gonna trust our code. I shouldn't really, but I am gonna for now. Okay, so this thing about procedures is that you don't have to, like I said before, you don't have to start the program by thinking, okay, what procedures will I need? What sort of elements will be encapsulated into small portions that I can reuse? You don't need to think about that. All you have to do is start programming your problem, like making a game or solving an exercise, and then breaking that problem down to the smallest thing. Like, just start with like the very first print message or the very first input from the user to create a game. And then after you start developing it, you'll be able to see the patterns that emerge. Like, oh, I think I'm copying this code a lot around, so I'm going to create a procedure for it. So that's you're going to hear the term semantic compression or refactoring. Semantic compression kind of has a long-winded explanation. It's pretty cool if you want to search for that. Refactor is more thrown around, but it's very useful as well. It means that the code is already there, but you're going to make it more organized and more optimal. Not in terms of performance or speed or execution, but in terms of code itself, how it looks for you, how it is it easy to use? Is it has a ton of is it error prone? Things like that. Okay, so creating procedures is a huge way, or functions depending on the language, is a huge way you can use to encapsulate these functionalities, right? To make it very simple. And you can see, okay, POW, oh, I don't need to know how POW is calculated when I call it. So these implementation details are kind of hidden away. But if I need to, I can come here and check and maybe change and maybe check if the result is actually correct and things like that. That's something very valuable. Okay, so we are coming to an end. Wow, we have just entered hour 5 of our live stream. Tomorrow I will have no voice whatsoever. But I think it was worth it. Do you guys think it was worth it? I hope you learned a lot with this video. I certainly loved creating it. And I took a lot of care of, explaining the best I could, answering questions whenever they appeared. Repeating myself a little bit to make sure that in different ways, make sure that people understood, people from the future that's gonna watch this video. I try to give you guys exercises and things that's gonna help you improve by yourselves. The more you can, and things like we talked a lot about variables. You can read more about them here. Statements, we talked about flow control, expressions. We talked about a lot of stuff that you can really go in depth if you want. And these are the next steps you should take. First of all, practice with the exercises, practice with your own ideas. Just think about a problem or a program that you want to try to create and just start creating them. Maybe you're going to find something that you can't do, and you can research that specifically, and then you'll be able to do that. So that's very valuable, to just search your interests, right? But there are also a lot of stuff that you can learn with that base that you learn, because this base is the fundamental of programming no matter how you're going to do it. You're going to do that with visual programming, like we did here, or with text, like you can do here, or with like a different language or a different tool, a different IDE, like a development environment. It doesn't matter. All that matters is that you have a solid foundational knowledge of this logic. And that's what I hope you can take away with this course, and that you took away, right? So I suggest that you practice a lot with these exercises, with your own projects, but then I'm going to give you a challenge, because like I said, like I showed you guys in the beginning, making games, or I kind of gave you a spoiler or what I was going to say, programming is about creating cool stuff, stuff you love, stuff you think it's great, stuff you want to put into the world, stuff you want to create, stuff that doesn't exist. And making games is one of the ways of doing this. There are certainly tons of things. Like people love to create websites or apps or solving problems, like maybe you have a startup idea, you need to program the solution, right? It was great. Yeah, thanks for the comment. I really appreciate that you liked it and watched through the whole thing. And maybe you should, you can watch the VOD, maybe you can speed up some parts and maybe go back and rewatch some parts. You can watch it at your own pace. That's really valuable as well. So at this point, you can start tackling bigger programs like games, like I showed you guys. These games are, I think they're a challenge. Don't get me wrong, they will be challenging, but it will be a challenge that you can try to face at this moment. And to help you with that, you can go to the Making Games page and read about how games are different, but how they are not. So it's kind of interesting. Kind of have an introduction and say how games are programmed with cool images and stuff. With links, of course, where you can learn it all. And the main thing is the embedded tutorials. I don't know if you guys saw that, so I'm gonna show you guys the main page again of Vizzcode. Just open up here. This is the main page you're gonna see. We pretty much covered this whole thing, the whole introduction in this course. The quick start is gonna be a review. It's kind of cool. If you wanna, after you create your own exercises and wanna go to the quick start, there are a couple tips there that I probably didn't cover. It's going to be interesting for you as well. The exercises are the ones that are there in the website, but this is where a whole new world opens up. And I will try to make a couple of videos about video game development in my channel as well. So if you're watching this on my YouTube channel, youtube.com/danzaydan, you can probably see that videos as well. But Vizzcode's channel as well, if you go to Learn and Support, so there's the Start Learning and Documentation, which link you here. Embed tutorials, which are these guys, and the video tutorials, which is the YouTube. You can come here and see the video tutorials yourself, as well as go to the Discord. Like we said, community is great. So a lot of people are going to help you help you if you have a specific question there, or if you find something that you don't know how to solve, we can help you with that. And start this journey that's a whole new thing that I think is going to blow your mind in terms of possibilities, in terms of creating cool things that you love, very interesting behaviors, and things like that. So I hope you really enjoyed. I hope you had a very thorough understanding, because this introduction was not only an introduction for beginners, but it's a complete course. So see, I typed that in the beginning. It's called a complete course because I covered a lot of stuff that you may see in other program tutorials, maybe taught as really a, not as a concept, but as a tool. So not as a concept, but just like a gimmick. I don't know how to say that properly, but the basic idea is I want you to understand the logic behind it, all that. And that's what I really tried to do, try to explain about computers, about programming languages, about compiling, what that means, about the executable, about all the features that you have at your disposal, like creating variables and how they work, how they can be different types, like arrays, things like doing expressions, arithmetic expressions, and arithmetically do operations. See, I learned that. And also do things like Boolean logic, like true and false, and or not, as well as comparison operators, all that, and hopefully breaking the code, controlling the code with ifs and whiles, and breaks and continues and fors, and then return statements like this. That's going to stop immediately the function. Hopefully, you can spend some time digesting all that and applying that to cool programs. And that's what I want to see. So if you create something cool with what you learn, or if you are learning, if you have some problem, please let me know in the comments. Please let people learn in the Vizzcode community that we want to really help you how to program. And we think this is like the easiest way, and we're still improving it. So if you have tips on how can we improve the platform to help you learn programming better and easier, can really tell us that we really wish to know your feedback, and then you can start, creating new things with those tutorials, for example. Okay, so that's it for me. So yeah, it was a pretty long course. I think I said everything I wanted to say, pretty much and more. So I hope you guys enjoyed it as well, and yeah, have fun programming. See you guys next time. Bye bye.